kamu akan belajar tentang cara memanfaatkan data dalam industri maupun bisnis.
Udah jalan.
Kedepannya, kamu punya peluang karir untuk menjadi seorang data scientist. Bagi kamu yang punya ide bisnis di bidang teknologi, kamu juga berpeluang untuk menjadi seorang teknologi entrepreneur atau biasa disebut technopreneur.
Oke, live streaming aman.
Aman ya, yaudah.
Fakultas yang kedua adalah Faculty of Business and Communication dengan 5 pilihan program studi. Prodi Business and Management akan membekali kamu dengan pengetahuan, bakat, dan pengalaman di lapangan yang dibutuhkan untuk memiliki kemampuan manajemen yang efektif. Mau jadi seorang digital marketer, ahli finance, atau entrepreneur masa depan? Ya mulainya dari sini. Nggak hanya belajar di kelas, melalui prodi ini kamu juga akan diajak mengimplementasikan pengetahuan kamu untuk bantu UMKM loh. Selanjutnya, ada Prodi Accounting and Data Analytics. Nggak hanya belajar akuntansi, di SGU kamu juga akan dibekali dengan kemampuan literasi data yang dibutuhkan di era industri 4.0. Dengan semua kemampuan tersebut, kamu akan lebih siap untuk jadi auditor atau ahli pajak di perusahaan multinasional. Suka dengan proses branding suatu produk atau tertarik dengan berita global terkini? Kamu sih cocoknya ambil prodi Global Strategic Communications. Di sini kamu akan belajar banyak mengenai media dan strategi komunikasi, supaya kamu bisa menjadi seorang PR profesional maupun jurnalis masa depan. Lulus dari sini, kamu juga akan dibekali sertifikasi Junior PR dari Perhumas Indonesia atau Digital English Journalism dari The Jakarta Post.
Ini berarti nanti kita datang lagi.
Di Prodi Hotel and Tourism Management, SGU bekerja sama dengan IMI Switzerland. Kamu bisa belajar langsung di negara yang terkenal dengan perhotelannya. Lulus dari sini, kamu bisa memiliki kesempatan menarik untuk berkarir di hotel berbintang maupun kapal pesiar.
J monitor.
Ingin jadi manajer atau pemilik restoran? Kamu bisa mempelajarinya di International Culinary Business. SGU bekerja sama dengan IMI Switzerland.
Bikin semua juga bisa masuk ke sana kalau mau.
Nggak cuma belajar ilmu kuliner di Eropa, kamu juga akan mempelajari bagaimana cara menjalankan bisnis kuliner yang diajarkan langsung oleh para profesional di bidang ini.
Buka ya, buat testing.
Fakultas terakhir adalah Faculty of Life Sciences and Technology. Berikut adalah pilihan program studinya. Pertama, Sustainable Energy and Environment. Kamu akan belajar untuk mencari tahu sumber energi alternatif bagi hidup berkelanjutan dengan memanfaatkan bahan makanan, energi, dan sumber daya air. Lulusan dari program ini bisa bekerja di sektor energi terbarukan maupun di perusahaan minyak, gas, atau perusahaan kimia.
Udah oke semua kan nih?
Kedua adalah Pharmaceutical Chemical Engineering. Kamu bisa mempelajari cara mendesain, mengoperasikan, dan mengoptimasi proses di industri farmasi. Saat lulus nanti, kamu bisa bekerja di perusahaan farmasi, kimia, dan perusahaan kosmetik juga loh.
Press conference sudah ABO 1, ABO 2.
Ingin terlibat di bidang kesehatan, nggak melulu harus jadi dokter. Kamu bisa terjun di bidang biomedical engineering. SGU menyediakan program studi ini supaya kamu bisa menjadi orang di balik penemuan vaksin serta berbagai alat kesehatan yang dibutuhkan dunia. USG, laser, stetoskop, semuanya itu ciptaan para insinyur biomedis. Terakhir adalah Prodi Food Technology. Kamu akan belajar mulai dari cara memproses bahan makanan mentah sampai packaging serta penyimpanannya. Setelah lulus dari prodi ini, kamu dapat bekerja di industri makanan dan berkontribusi untuk menyediakan sumber makanan di Indonesia atau bahkan dunia. Mahasiswa SGU juga memiliki segudang prestasi, mulai dari prestasi akademik seperti beasiswa dari lembaga internasional dan juara dalam berbagai kompetisi, hingga prestasi non-akademik seperti olahraga, beauty pageant, dan sebagainya. Baik berkiprah di depan layar maupun di balik layar, berbagai alumni SGU kini menyebar dan terus berkontribusi bagi dunia. Banyak lulusan kami juga bekerja di perusahaan multinasional di dalam dan di luar negeri. Umumnya, setelah lulus dari SGU, alumni kami hanya perlu menunggu kurang lebih 1 bulan untuk mendapatkan pekerjaan. Malah ada juga yang sudah mendapatkan pekerjaan sebelum kelulusan. Berbicara tentang fasilitas, SGU punya berbagai lab yang bisa dimanfaatkan sesuai dengan program studimu. Untuk fasilitas olahraga, SGU punya lengkap banget. Kamu tinggal pilih jenis olahraga apa yang kamu suka. Untuk mendaftar, kamu bisa menuju ke link yang ada di description box dan mengikuti alur registrasinya aja ya. Oh iya, bagi kamu yang berprestasi, SGU juga menyediakan berbagai pilihan beasiswa up to 100% loh. Jadi, kamu bisa banget memanfaatkan kelebihan ini. Jika masih ada yang belum jelas, kamu bisa langsung menghubungi hotline kami di 0811 80 10 600. Jangan lupa untuk follow akun Instagram kami di @swissgermanunit atau kunjungi sgu.ac.id untuk info lebih lanjut. Dalam beberapa tahun ke depan, persaingan di dunia kerja sudah pasti akan semakin ketat. Apalagi ditambah kondisi pandemi, tidak semua orang cukup beruntung untuk mendapatkan pekerjaan. Kamu akan bertemu dengan para saingan pencari kerja yang saling memperebutkan bangku di perusahaan. Di tengah-tengah ketidakpastian ini, kamu bisa melangkah dengan percaya diri di masa depan dengan gelar sarjana dari universitas dalam dan luar negeri, sertifikasi dari industri incaranmu, serta pengalaman kerja dengan para profesional di bidangnya. Pastikan untuk tidak salah melangkah and secure your future with Swiss German University. Terima kasih dan sampai jumpa di kampus!
menyelenggarakan program pendampingan dan pelatihan UMKM dalam masa pandemi COVID-19. Program ini didanai oleh CCSF, Central Community Service Fund, dari Universitas Swiss German University untuk benar-benar memberikan kontribusi dan support kepada UMKM yang terkena dampak akibat COVID ini. Salah satunya hari ini adalah menyelenggarakan program pelatihan secara online yang sebelumnya sudah didahului dengan kegiatan pelatihan secara online. Yang hari ini kebetulan fokus untuk praktikum bagaimana membuat batik dan kemudian tentu memasarkan batik ini ke segmen market yang tepat.
Berarti Sebagai salah satu penggerak UMKM di Kota Tangerang Selatan dan pengurus dari Masata DPC Masata Kota Tangerang Selatan, saat ini kami memberikan bimbingan kepada para pelaku usaha dari pendampingan Masata untuk memberikan pelajaran tentang teknologi batik dan pewarnaan. Kami optimis dalam memberikan pelatihan ini, para pelaku usaha pada masa pandemi ini bisa bergerak dan bisa melakukan aktivitas yang positif, tidak mengurangi daripada penerapan protokol kesehatan.
Yang diadakan oleh Universitas Swiss Jerman bekerja sama dengan DPC Masata Tangsel. Saya merasa diuntungkan sekali pada kesempatan ini saya mendapatkan banyaknya pengetahuan terkait dengan bagaimana proses suatu pembatikan.
Universiti Malaysia Sabah UMS dengan kerjasama Swiss German University SGU di Indonesia sedang menjalankan penyelidikan mengenai kaedah mengurangkan jangkitan penyakit tuberkulosis TB dalam usaha menangani peningkatan kritikal selain penularan penyakit TB di negeri ini. Kerjasama penyelidikan bernilai RM400,000 itu masing-masing mendapat pembiayaan geran sepadan UMS berjumlah RM200,000 dan RM200,000 daripada SGU bagi tempoh 2 tahun bermula tahun ini.
Menurut Pengarah Institut Penyelidikan Bioteknologi UMS, Dr. Zarina Amin, kerjasama ini hasil daripada pertemuan dalam Simposium Bioteknologi Antarabangsa Anjuran UMS tahun lalu.
Kami di UMS ada mempunyai makmal tahap 3 biokeselamatan tu kan, di mana kami boleh culture BSL-3 organisms yang macam TB tu dengan selamat. Inilah specialty of UMS. Kita sebenarnya perlu showcasekan yang UMS ni ada begitu banyak research facility dan research strength.
Beliau menyatakan perkara tersebut kepada pemberita selepas Simposium Bioteknologi Antarabangsa kali ke-6 Anjuran UMS dengan kerjasama Asian Federation of Biotechnology di Kota Kinabalu. Sementara itu, Timbalan Pengarah Kajian SGU Jakarta Indonesia, Dr. Kholis Abdul Rahim Audah memberitahu kerjasama antara kedua-dua pihak dalam projek ini melibatkan hasil bumi yang terdapat di Borneo seperti bakau yang berpotensi menjadi sumber perubatan.
So far we are in the process of extracting as many as possible the mangrove extracts, and later on we will test or screen all those extract towards tuberculosis and also as well as dengue viruses.
Mengenai
Bunda pulang. Bunda lapar. Iya nak, Bunda masak bentar ya. Aduh. Aduh, masih kurang. Kurang apa ya?
Kelihatannya ribet banget, Bun.
Siapa kamu?
Nama saya Nyai Tumpi.
Dan saya punya solusi buat Bunda.
Risoya terbuat dari tempe fermentasi lanjutan dan rempah-rempah alami khas Indonesia. Pasti enak, Bun.
Instan begini? Emang bergizi di mananya?
Gak perlu khawatir, Bun. Risoya tentunya bergizi karena tempe itu rendah lemak, mengandung protein tinggi dan juga kalsium yang baik untuk tumbuh kembang anak.
ini baru pas.
Makanya Risoya, pilihan Ibu Bijak.
Jadi setelah 4 tahun kuliah, halo, selamat datang di Swiss German University. Hari ini aku akan mengajak kamu untuk melihat kenapa kamu harus kuliah di SGU. SGU adalah universitas berstandar internasional pertama yang ada di Indonesia. Kami memiliki program International Double Degree. Jadi setelah 4 tahun kuliah, kamu bisa mendapatkan 2 gelar sekaligus, yaitu gelar sarjana dari SGU dan bachelor degree dari universitas partner kami yang berada di Jerman atau Swiss. Meskipun dapat gelar dari luar negeri, namun 90% proses perkuliahan dilakukan di Indonesia di kampus SGU yang berlokasi di Alam Sutra, Tangerang. Proses kuliah dilakukan dengan maksimal 25 mahasiswa dalam satu kelas. Karena berstandar internasional, seluruh materi perkuliahan juga akan disampaikan dalam bahasa Inggris. Selama kuliah di SGU, kamu juga akan diwajibkan mengikuti program magang sebanyak 2 kali. Magang di Indonesia pada semester 3 dan magang internasional di semester 6 yang dilakukan di Jerman atau Swiss. Kamu berkesempatan untuk magang di ratusan perusahaan partner SGU di Eropa supaya kamu siap berkompetisi di era industri masa depan. Tenang aja, selama di SGU kamu akan dipersiapkan oleh para dosen kami yang 90%-nya merupakan lulusan dari berbagai universitas ternama di luar negeri. Salah satu persiapannya adalah bahasa Jerman yang akan diajarkan kepada semua mahasiswa mulai dari basic. Jadi, kamu juga udah lebih siap untuk magang di Eropa. Di SGU ada berbagai pilihan program studi yang telah disesuaikan dengan kebutuhan industri masa depan atau yang kini disebut dengan Industri 4.0. Yuk, kita telusuri satu persatu. Fakultas yang pertama adalah Faculty of Engineering and Information Technology dengan 3 pilihan program studi. Di program studi Mechatronics Engineering, kamu akan dibimbing untuk mengenal berbagai pendekatan mesin, robotic system, elektronik, dan computer science. Dalam beberapa tahun ke depan, insinyur mekatronik akan semakin dibutuhkan dunia. Kamu akan memiliki kemampuan untuk merancang industri otomasi dan mendesain smart products. Seluruh lulusan Mechatronics Engineering SGU juga akan otomatis mendapatkan sertifikasi dari Siemens Certification Program. Pada Prodi Industrial Engineering, kamu akan belajar tentang cara mengoptimalkan sistem agar berjalan dengan efektif dan efisien. Maka dari itu, peluang karir seorang industrial engineer sangat luas. Kamu bisa mengambil peran di industri keuangan, teknologi,
Hello. Good morning to Dr. Holis Abdurrahmin Auda, Director of Academic Research and Community Service, Swiss German University. Mr. Muhammad Riyad Rizki Adam, ST MSM, Chairman of SGU Symposium 2021. Dr. Insinyur Yosman Bustaman, Chairman of SGU Senate and Head of SGU MM and MBA Program. Mr. Nuki Agia Utama, PhD, Executive Director of ASEAN Center for Energy, distinguished guests, fellow lecturers, and beloved students. I would like to welcome you all to Day 2 of SGU Symposium 2021 with the theme of Achieving Competitive Advantage for Business Turnaround through Innovation during and Post-Pandemic Era. I am Dave Simorangkir, and I am your host for this event. SGU Symposium 2021 is our annual scientific program to disseminate research and community service activities. And this year, it is also in conjunction with the International Business Forum. Today, we have 19 presenters for Central Research Fund, CRF, Kemenristek BRIN Fund Central Community Service Fund, CCSF, and student paper projects. In the International Business Forum, we have 10 presenters giving you the thesis related to marketing, strategy, and organization. And in addition, I would also like to inform you that there will be door prizes at the end of the sessions. So make sure that you stay tuned so that you do not miss the chance of winning a door prize. Coming up next, what we all have been waiting for. We are very fortunate to have a wonderful keynote speaker today. Our keynote speaker earned his PhD degree in Energy and Environment Technology in Joint Graduate School Energy and Environment KMUTT, conducted his postdoctoral study in Energy Science in Kyoto University, his master's degree in Built Environment in London South Bank University, diploma in Hochschule van Arnhem, Nijmegen and Nijmegen, and Bachelor of Science in Structural Engineering in Universitas Diponegoro. Currently, he is Executive Director of ASEAN Center for Energy, was previously President Director of Baryon HP, and Senior Energy Consultant for Nike, among other prominent experiences throughout his career. Ladies and gentlemen, please welcome Mr. Nugi Agia Utama, PhD.
Thank you, Dave, for the nice introduction. Good morning, good afternoon, and good evening, everyone, wherever you are. I think today is very great pleasure. Again, thank you very much for inviting me to this SGU Symposium. I will share my slide. For these opportunities, I may present the energy status in Southeast Asia, the future trend, as well as our current activities related with the energy transition. We all know that Southeast Asia is the fastest growing region in the world. So if you're looking at 15 years back, so the primary energy supply growing from 422 million ton oil equivalents, reaching 672. While it's on the final energy consumption, increasing from 260 to 391. This is one of the biggest increases of the primary energy supply as well as the final energy consumption. If you want to revert back on the demographic condition, Southeast Asia populated by more than 655 million people. And surprisingly, the region already reached almost 90% electrification. I think it's one of the good indicators that the region already reached sort of modernization with the numbers of the electrification ratio. If we're looking at electrification ratio, then we're looking at also on the installed power capacity. The latest information that we have, the total installed power capacity reaching almost 253 gigawatt and generating approximately 800 terawatt hours. And this one showing that the increasing of the electricity demand leading to the industrial era. Some other key figures that we can see on this slide is the increases of the RE share in the energy supply. RE stand for the renewable energy, approximately around 14%. And also the share on the renewable energy on the installed power capacity, which is reached almost 37%. So all of those are achieved by these all 10 member states, and the activities that we have annually. We always, having regular meetings in the region. So if we're looking at the primary energy supply, all of these primary energy supply dominated by the fossil fuel. If we're looking at over here, the domination coming from gas, oil, as well as coal. Gas usually being used on the industrial sectors and small part in the transportation and also power generation. So we're looking at also on the oil, steadily increase, but regarding the coal, quite significantly increase around 12% in comparison in 2005. While it's on the oil side, it's a bit decreased, around 7% in comparison in 2005. And gas itself also decreased steadily around 2.2% in comparison in 2005. So the share of coal in energy supply increased 14.2 in 2018 and projected to rise steadily over the coming decades. And the share of biofuels has remained stable over the last few years. A slightly increase from 2017 to 2018, around 2.3 million ton oil equivalent. So basically, the whole energy supply in ASEAN still based on the fossil fuel, which is counted around 83%. If we're looking at on the renewable energy status in Southeast Asia, so over here we can see that the RE status in energy supply dominated by the biomass, which is counted around 6.7%, followed by the geothermal around 30.1%, hydro around 2.4%, and the remaining approximately around 1% equally distributed into biofuel and others renewable energy. It is quite good news for us that the renewable energy in total primary energy supply is increasing quite drastically, starting in 2006, which currently we increased more than 5% up until 2018. And usually, mostly is goes to the power sectors. If you're looking at on the right side of the figures, the RE in installed capacity by energy source, so dominated by the hydro, which is 72.9%. This is for overall Southeast Asia, followed by geothermal, 5.8%, bioenergy around 11%, solar PV is around 7.4%, and wind 2.8%. If you're looking at on the country base, the most RE in the installed power capacity is in Lao PDR, which is 75% approximately, dominated by the hydro, accounted around 5.5 gigawatt, and also Cambodia, around 62%, it is dominated by the hydro. What about Indonesia? In our country, the share of RE still accounted around 15%, and again, still dominated by the hydro, around 5.7 gigawatt, and followed by the geothermal, approximately around 2 gigawatt. The other country, such as Cambodia, Myanmar, and also Vietnam, approximately having around 20 up until 55% in the total installed power capacity coming from renewable energy. Why we need to looking at the whole perspective or the whole landscape of energy, the current status and the trend, as well as the potential of RE. Because if we're looking at in our projection, above x-axis is the export, below the x-axis is the import. So today, in 2020, somehow we are still in the balance amount between how much the energy that we export and how much the energy that we import. However, if we're looking at throughout the next 20 years, in 2040, if you see over here, this region will 100% becoming the net importers of all fossil fuel. You name it, all of the fossil fuel. Coal that currently we are abundantly we will import. Natural gas, we will import. And oil, of course, we already becoming the net importer of oil since 2005, regionally. So I think it's quite alarming for us to see that our dependence on fossil fuel, which is, as you saw before, 82% in the total primary energy supply, will be rely on the imported fossil fuel. So how we deal with this? How we try to overcome the issues politically, also in terms of the regulation. So in Southeast Asia, we have a blueprint energy activities. We call it the ASEAN Plan of Action for Energy Cooperation, or APAC. Maybe some of you not familiar with this terminology, but the APAC, or ASEAN Plan of Action for Energy Cooperation, already being around 50 to 20 years. So in this stage, we having 2016 to 2035, a bulk of activities, a bulk of strategies up until 2035. So we divide it into yearly activities. So in this APAC 2021 to 2025, we have a theme, we call it Enhancing Energy Connectivity and Market Integration in ASEAN to achieve energy security, accessibility, affordability, and sustainability for all. And the sub-theme that we have for this 5 years APAC 2021 to 2025 is accelerating energy transition and strengthening resilience through greater innovation and cooperation. So there are some keywords very important that we have to keep in mind. First is the energy security. Second is the energy accessibility. Third is the energy affordability. And of course, those four should be sustainable enough. And then to achieve those four main targets, we have to accelerate through energy transition. You saw previously the energy coming from fossil fuel dominated in the total primary energy supply, and for the next 20 years, 30 years, we are going to be the net importer. So the energy transition is a must. We have to see how to deal with this current energy from fossil fuel. We need to make it more efficient. We need to introduce more new technology to make it again becoming advanced. And then we also to introduce alternative energy as well as renewable energy. And this one to strengthening resiliency. And of course, those will need a support on the research and development. That's why we have innovation and cooperation. Innovation is important on the R&D side, but cooperation is also important. We need to learn from other regions. We need to learn from the modern countries, how they deal with the power generation, how they can make the power generation very efficient, and etc. So the ministerial level already have series of meetings. The last meeting that we had is the 38th ASEAN Minister Energy meeting in 2020 in Vietnam to endorse these blueprint activities or the APAC activities. And all of those countries in Southeast Asia are already aware and already try to focus on the security, accessibility, affordability, and sustainability by strengthening resiliency through innovation and cooperation on the pathways of the energy transition. So also we do have energy target. We call it the regional energy target in 2025. Two of the very famous target that we have is the renewable energy share around 23% in 2025 for coming in the total primary energy supply of TPS, and reduction of the energy intensity up to 32% reduction of the energy intensity in comparison with 2005 levels. And this 23% will be supported by around 35% VRE, variable renewable energy, on the installed power capacity. So apart from 20% in the RE of the TPS, we have to have also 35% in the total installed power capacity, all of the country in Southeast Asia. So to do that, we have 7 program areas. So I don't want to explain one by one. So basically, this 7 is very important. We're focusing on the interconnection. We call it the ASEAN Power Grid to expand regional multilateral electricity trading, strengthening grid resiliency, modernization, and promoting clean and RE integration. We do have also Trans-ASEAN gas pipeline, to pursue the development of the common gas market. We also have coal technology, which is clean. We call it the clean coal technology, as you may refer to the previous slide that I have. Coal is still dominant in the power generation, so we need to improve coal to be cleaner. So we do have a lot of activities, coordination, cooperation on the cleaner coal technology. And also we have energy efficiency and conservation. Number 5, we have renewable energy, very strong activities, and being supported by almost all of the region in the world. And also we have a policy planning, and last but not least, the civilian nuclear energy. Why the civilian nuclear energy is also important over here? Because whatever it is, we need to have a very steady and stable base load. And when the fossil fuel is depleted, coal is depleted, natural gas is depleted, and also oil is depleted, then we need to have a more steady supply of electricity. And nuclear currently available in the market can provide those basic. So the APEC target, how to achieve it? We develop 3 scenarios. First is the baseline scenarios, when we only refer to the power development plan, and on the power development plan we also referring to the somehow business as usual activities. So that's on the orange line, on the bottom line, on the renewable energy share in total primary energy supply. So we'll be looking at the baseline until 2040. The share of RE will be approximately steady from 13% to 14%. And then to increase RE, we follow whatever countries' regulation and policy on the power development plan, as well as the energy efficiency and RE in each member states. So over there, we incorporate with our study, then we develop the second scenario, we call it the ATS, or ASEAN targeted scenarios. The gray line. So in the targeted scenarios, when we incorporate all of the policy regulation coming from member states, slightly increases from 14% in 2040, becoming 22% in 2040. Whether is it enough? If you're looking at the APEC target, 23% in 2025, I think this ATS target is not enough, because ATS target showing us that in 2025, we can only reach almost 18%. We still miss around 5%. So what happened next, that we try to develop the next scenario, we call it the ASEAN APEC target, or ASEAN APEC scenarios, or we call it APS. By having 23% in 2025 and increasing steadily into 28% in 2040, and it is possible. What about the energy intensity reduction? You saw previously that our target is in reducing the energy intensity 32% from the baseline 2005. So by the baseline, we can only achieve somehow 21% in 2018. But surprisingly, even with the baseline, we can achieve already 23% in 2025. This is the scenario that we project. So by having more activities or more effort on increasing the efficiency on the power sectors, on the transportation sectors, and also industrial sectors, all 10 member states commit to reduce the energy intensity up to 28.9% in 2025. But this one is not enough, since our target is 32%. Then the APAC target, like it or not, we have to really reduce the energy intensity in 2025, which is 32%. If we follow the APAC target or APS target, if you're looking at on the yellow line over here in 2040, we can achieve such tremendous energy intensity reduction up until 50% in 2040. So what will be the benefit, the socio-economic benefits? Currently, a lot of countries are looking at our region, when or how the GHG emission correlated with energy sectors will be reduced. So with the APAC target, with the APAC agreement, the APAC backbone energy sectors activities, so we try to calculate and we try to predict in 2025, somehow we can reduce approximately around 500 to 700 million ton carbon dioxide equivalent in 2025. And mostly the reduction goes in the power generation. In 2040, we plan to reduce in more than 1,700 million ton oil equivalent. And again, most of those coming from the power generation. As you may know, that the power generation currently in Southeast Asia dominated by coal. So this is our task to reduce, not just only slicing down the use of coal, but to enhance and improve the coal in the power generation, as well as increasing steadily the RE share in the power generation as well. So we're looking at first, over here, if you see the energy-related GHG emission, the biggest contributors is the power generation, 42%, as I mentioned, in 2040, and currently it's on 35-38%, and followed by the transportation sector, around 20-25% currently, and again 26-25% in 2040. So looking at these power sector, transportation sectors. In the transportation sectors, currently dominated by the road, private passenger vehicles, also lightweight vehicles, heavy-duty vehicles, and so on. Small amount on the railway system, and also small amount on the vessels, as well as the airplane. So focusing on the land transportation sector. So it is predicted that total road vehicles in ASEAN will increase tremendously up to 591 million in 2040. Yeah, I think it's not surprising that motorcycles also quite large in terms of these numbers. But in terms of the energy consumption, of course, at least four-wheel chairs, four-wheels car will be the best, the biggest consumption of the energy. So if you're looking at the targeted scenarios by the member states in 2025, there are some increases of the consumption in 2025 based on the government plan. So oil is one of those. It is predicted that the oil will increase around 38 approximately, and then also the biomass or biofuel somehow also increase. So I think this one showing that at the moment the government try to still not move away from the oil and also try to increase the biomass. While it's on the 2040 in the demand reduction mostly goes in the oil around and also approximately increases of the biomass around half of it. So most of the oil in the transportation sectors will be replaced by the biofuel in the next 20 years. I think it somehow is quite good news since Southeast Asia is abundantly available by the the availability of the biofuel resource is really having us a positive advantage. So we're looking at the power generation. So currently the installed power generation capacity is around 1 million gigawatt hours. It is, as I mentioned, it is dominated by coal around 40%, coal and then oil 32%, and natural gas around 15%, and the remaining is RE. Hydro accounted quite big regionally, around 17.38%. In comparison with Europe and United States, 1 million gigawatt hours is 1/3 of Europe installed power, generating power currently we have. But if you're looking at the increases of the potential demand in the next 20 years, we projected that we're going to surpass the current European electricity consumption. So meaning, if we're looking at ourselves 20 years from now, somehow our livelihood more or less looks like Europe right now. And then if you're looking at the United States, we're still around 1/4 comparing to the United States. But another 3 decades, it is projected that Southeast Asia will also surpass the United States in terms of the energy consumption, specifically on their power generation. So it is a good news, but also somehow create a big challenge. So looking at the energy supply that we have to reduce coming from the fossil fuel because of the scarcity, because of the import that we're going to have in the next 20 years. That's why we have to a bit try to move on the how to move away from the fossil fuel. Doesn't mean that we take them out, all of those, because in ASEAN, we really want to have that the all primary energy treated fairly. We cannot say that RE is best in comparison with coal, for example, or oil is natural gas is better than the wind power, for example. No, we try to, as much as possible, to treat all of the primary energy fairly. Again, for making the energy supply affordable, secure enough, and resilient enough, and of course, sustainable enough. So that's the bottom line of this energy perspective in Southeast Asia. So how to decarbonize the ASEAN power sectors? So basically, we try to increase the share of RE through hydro, geothermal, solar, wind, and of course, biomass, which is abundantly available in this region. And steadily, we reduce our dependency on oil, which is currently already as a net importer in Southeast Asia, and also reducing our dependency on coal and gas. So that's how we try to do by also try to introduce HELE, the high efficiency and low emission coal technologies, such as supercritical and ultra supercritical, and of course also phase out the fossil fuel-based power plant gradually. So that's quite important for us to move from fossil-based fuel economics through the transition to be more independent and more reliable affordable fuel economics, which is of course will not be reliant on one or two primary energy only, but maybe various type of the primary energy supply will be there. If you're looking at on the power generation, these pictures maybe looks complicated, but I think it's not that complicated. These are very simple to understand. So basically, in the region, we try to be connected, starting from Java, Sumatra, Singapore, and Malaysia, goes up to Myanmar, Thailand, Laos, Vietnam, Cambodia, and also Vietnam, Laos, Cambodia, and also Thailand. So basically, this is the first line of interconnection that they already developed. And the second one is up until Philippines, from Sumatra, Singapore to Sabah Sarawak, and also from the Kalimantan or Borneo Island to Sabah Sarawak to Brunei and up to Philippines. And it is also assuming to be connected between Sumatra to Kalimantan as well as Java to Kalimantan. And then with this study that we have, supported by the US government, so we can figure out that it is possible to accommodate wind power in the Vietnam areas and also solar power to supply the energy, to supply the electricity through the power, interconnection power generation. So it is technically feasible and also economically feasible. So there is no issues. So the most importantly is that the political wills, and also we need to prepare regulation. The additional planned interconnection project will unlock a potential power trade. So by doing this ASEAN power grid, we will also unlock the potential of new trading scheme that we can trade electricity from one country to another. And the potential of this is around 145 terawatt hours, which is increasing twofold from the current level. So basically, this ASEAN power grid will increase. First, economic possibilities will be increased, and second, grid stability. The grid stability is important. When we try to increase renewable energy in the grid, the bigger the grid, the better the VRE or variable RE can be introduced. Yeah. So the ASEAN power grid is very important, and fortunately, 3 years ago, Laos, Thailand, Malaysia already signed an agreement, and they already started trading each other, and it is successfully done. And this year, hopefully, Singapore will come through, and I'll keep our finger crossed. Indonesia will follow suit. Hopefully next year, approximately. I'm not sure. It's depending on the Indonesian government. That's my opinion. So, with the 44% of the capacity of RE, it will translate around 64 terawatt hours of RE will be introduced in this ASEAN power grid. I think it's what's significant for us to really support this ASEAN power grid. So based on the study, the same study, Indonesia can supply most of these RE in the ASEAN power grid, followed by the Vietnam, Thailand, and Philippines, 19, 15%, 10% respectively, and also Malaysia 12%. But we're looking at on the cost perspective, sure, the cumulative production cost of the if we introducing the optimum RE, the green dotted, is the highest. Yeah, in comparison with the high RE and also applied pressure. So introducing the optimum RE, there is some consequences. This is the consequences. The consequences is the cumulative production cost and also fuel costs. However, with the high RE, with high RE, optimum RE meaning that we can combine between fossil fuel and RE, try to reach the optimum percentage of RE, but maintaining the RE. But by having the high RE meaning that we install more RE regardless there is availability of the fossil fuel at the moment. So with the high RE, we can have quite significant reduction of the cumulative production costs as well as fuel costs. However, if you're looking at the total fuel costs, high RE, the yellow dotted over here, show the highest in comparison of the base or optimum RE. Base is mostly by the fossil fuel. So base and optimum RE is in combination with the fossil fuel. And base scenario, the blue one is the higher percentage of share of the fossil fuel power generation. But if you're looking at the thermal generator build cost, of course, high RE will be the lowest. And also the operation maintenance cost, high RE also the lowest. But in the solar build cost, to build a solar, the high RE, which is we try to introduce solar more, will be the highest. The wind also will be the highest in terms of the high RE. And interconnection grid costs, as I mentioned previously, high RE also having a higher cost. So this one is very important for us to understand how we will design a policy in order to make sure the mix of energy supply, the mix in the power generation is affordable enough, resilient enough, and of course sustainable enough for all of the people in member state. Thank you very much for the time. I hope that I'm not talking too much. Again, thank you very much, and back to you.
Thank you, Mr. Nuki, for the informative and very useful speech. Thank you for sharing the key strategies for APAC Phase 2, which is running right now up until 2025. We wish you all the luck on your journey and process to energy development and consumption for a better world. Once again, thank you, Mr. Nuki. Okay, so for our upcoming invited speaker, I would like to invite Dr. Heri Sutanto, Head of SGU Renewable Energy and Energy Conservation Research Center, and Head of SGU Chemical Engineering Department to introduce and moderate the session. Dr. Heri, please take it away.
Hello, good morning, ladies and gentlemen. Welcome to the Renewable Energy, Environment and Energy Conservation session on the SGU Symposium 2021. For the first session, we have a very special guest from Universitas Indonesia, Professor Misri Gozan. I would like to welcome Professor Misri Gozan. Before Professor Misri presenting his speech, his topic, I would like to read a little bit about his CV. Profesor Misri Gozan is Guru Besar Teknik Kimia from Fakultas Teknik Universitas Indonesia, bidang Rekayasa Limbah Industri. Currently, he is the Chairman Executive Committee of IAB PII, and also Ketua Lembaga Akreditasi Mandiri Teknik atau LEM Teknik. He is also one of the 500 peneliti terbaik nasional versi Sinta, and also Ketua Program World Class Professor FTUI Dikti. Ladies and gentlemen, please welcome Professor Misri Gozan.
Yeah.
Hello, Prof.
Yeah, very good morning, Mr. Moderator. Very nice to have your introduction from me. Thank you for introducing me and also allowing me to deliver my speech. I hope today in this very how many percent? 80% already. So we will have a very good discussion, hopefully. So I would like, may I? 20 minutes. Okay, I will share my screen. Agak beda ini tampilan di komputer.
We can see that.
You can see this full screen or
no, the PowerPoint.
Okay, just a minute.
It's not the full screen display.
Normally there is and
Yes.
Now full screen.
Yes, Pak.
Okay, thank you. So I would like to discuss a little about aspects to consider in the conversion of oil palm solid waste to bioenergy. This is based on my experience in working with this oil palm solid waste. Actually, what I mean by bioenergy is not really a single bioenergy. It is a kind of biorefinery. Why? Let's see. Saya kayaknya ada yang salah sebentar ini. Oke. Sekarang terlihat full ya? Is it full screen now?
Yes, Pak.
Okay, good, good. Why? I don't know why.
Now it's already full screen, Pak.
Okay.
Yes.
Yes. What is really the problem with solid waste? Let's see the mass balance here a little bit. Don't worry too much about the calculation, but I made it easier. This is, for example, 100% of fresh fruit bunch we got. Then some very little amount ended to in the form of chaff. Very little. What we need is to have this fresh fruit, which is around 66 to 75% of the mass. Then we also have, after crushing this fresh fruit bunch, we got about 23 to 28%. This is a solid waste. The upper one is also a solid waste. This is also the solid waste. And then after processing the fresh fruit, we also have some waste. Some are liquid in the liquid form, and mostly are in the form of solid. So we can see here that the volume of empty fruit bunch, actually this is EFB, can reach up to 50.8 million tons annually. Some people say less than that, some people say it's more. So I get the middle number here. Moderate number here. Total other solid palm oil waste can be more than 90 million tons, plus oil palm fronds and oil palm trunks, which is not covered by this mass balance, can reach 150 million tons per year, or 160 or 140 million tons per year. This is a huge number. This is why this is a very important that we have to consider. So it is the oil industry, palm industry is a huge scale business. This is about 20 to 32 billion US dollar, Indonesia alone. And in Malaysia, we have 6 million hectare. Indonesia have 17 million hectares. So you can imagine that we have more than Malaysia, although our productivity is less than Malaysia in terms of the hectare per hectare, but we still have the more production than Malaysia. But we have environmental problem. How? Because we have to reduce waste to almost zero in order to sell it to the European regions, and we also have to deal with the issue in the soil fertility. That's why we have to increase the soil fertility. So if we can use this solid waste as composting, for example, we can increase the soil fertility. But also, if we can solve this solid waste, not only for not for combustion, as it is a common practice nowadays. So it means that we can reduce the greenhouse gas effect. We can reduce the CO2 from the fossil fuel and methane utilization. So these are some environmental issue that we can deal with when we would like to use the solid waste as the bioenergy. But we can also use it for other purposes. I think I have to speed up a little bit because we have a limited time. So we are going to concentrate or to focus on this solid waste. So solid waste basically, as you know, as oil palm empty fruit bunch, and also mesocarp, and also palm kernel cell, and also oil palm frond and trunk. So mostly it consists of cellulose, lignin, and the rest is hemicellulose. For the case of the oil palm anti-fruit bunch, the lignin is so high, it's 23 to 29, and also the palm kernel shell is very high lignin. So this palm kernel shell is not very easy to deal with. So that's why we would like to deal with the empty fruit bunch more in Indonesia, because the volume is much bigger, and also it has less lignin than the palm kernel cell. But the problem is that we have to make pre-treatment first in order to separate the fiber, the lignin, from the bonding to the hemicellulose and the cellulose inside. Otherwise, other treatment or other process cannot attack this very strong fiber. So basically, there are chemical treatment, acid-based method, a neutral state-based method, and base-based method. I don't want to go into deep into this, but there are some advantage and disadvantage of using this chemical and also physical treatment. There are a lot of it. But the most important thing is that pre-treatment is very pivotal. Why? Because it is the key and the side products of this pre-treatment. For example, if we use acid pre-treatment, we would end up with some residue, not only the sugar residue, but also we will end up with the HMF or hydroxymethylfurfuran. If we would like to produce bioethanol out of it, then we have to separate the HMF or furfura, because those are toxic to the fermentation. But you know that we can also use the HMF itself as a product, because HMS is higher the price than than the bioethanol itself. I will show you later on. So we have to discuss, or we have to consider what kind of products we really want. For example, here, if we would produce bioethanol, then we have to concentrate on, we have to focus on how to get all the cellulose polymer into the monomer of sugars. And also, if we can use the what do you call it, modified or genetic engineered fermentation with the microorganisms, then we can also have the benefit of hemicellulose to become the monomer. Of course, the monomer is different. It's not hexose, but pentose with a C5. So, you know that Saccharomyces cerevisiae cannot deal with the pentose to ethanol. They can only use the hexose. But with the genetic modified microorganisms or Saccharomyces cerevisiae, we can use pentose to become ethanol. That is one of some important points that we have to think about. So I'm going to continue with the possibilities or the menu. What kind of options we have instead of only making bioethanol or bioenergy? What other options available on the table that we have that we can use our biomass into products? So, for example, here, if we from the EFB, we can get aromatics. What should we do? Alkali pretreatment followed by lignin recovery from black liquor and nitrobenzene oxidation from lignin. Also, we can also have ABE or acetone ethanol butanol, but this time there is no interesting yield from this is the best one, Clostridium acetobutylicum ATCC 824, but so far there is no more not interesting process because the yield is only less than 6% or maybe 2%, very little. And I have tried myself, it's very difficult because this ABE process is strictly anaerobic process. We can also make a bioplastic, for example, polylactic acid or polyhydroxybutyrate with the hydrolysate polymerization by Bacillus cereus. I have tried in my lab. This is very good for the. This is very good result, and polylactic acid is very good for the biomedical purposes. We can also make a biochar, but the biochar is a very a little bit a bit low added value, so it can be used as bioenergy itself. We can use also for other purposes here. Biocomposite, for example, this is very interesting because the price is very high. A graph polymer, of course, this is a higher price. Lignin graph polymer, graphene nanoseed. There are a lot of process that we can deal with. So we have to be careful what kind of pretreatment we should choose. There is also possibility to have a lactide acid. This is a bit difficult because we have to use the metal catalyst. The metal catalyst is not. This is a very common use nowadays, but it is not. Is it not suggested? Because in the future we would like to have a non-metal process because we can use the lactic acid to produce polylactic acid, lactide to produce polylactic acid to open ring polymerization. Then this is very good for the biomedical purposes. And this is formic acid, furfural, and linoleic acid. I'm going to use this example in at the end of my presentation today. We can also still have nitrocellulose, for example. This is very delicate process. We have to separate the nitrocellulose in the at the end, and also biohydrogen. We have to use the pretreatment by ammonia fiber expansion of FX, and then we can use fermentation by Enterobacter. We can use also the biosolid for bio oil. This practice has been widely applied nowadays because this is not very difficult. But I can suggest that if we use fast pyrolyzation, it is much better than the slow pyrolyzation. We can end up with a very nice and very good result of bio oil. We can separate the very high added value of the bio oil itself. And other biological products here, for example, cellulase, but this is not very good result at this moment. I found in the review. I tried myself also, but still it's not very promising. Biomethane and bioethanol, of course. From the palm kernel cell, we can produce also ABE, activated carbon. This is mostly we can use in Indonesia. We needed a lot activated carbon for wastewater treatment or for other industrial purposes. So I would like to jump. How many still my time?
Around 5 to 7 minutes.
5 to 7 minutes. Okay. So this is mesocarb fiber. We can have also a graph polymer, acetone, ethanol, butanol, and biomethane. We have to select what kind of pretreatment, what kind of process that we have to do. For example, if you would like to produce biomethane, then you cannot use acid pretreatment. You have to use a biological pretreatment. For example, by oyster mushroom, followed by co-fermentation with coda and pome as inoculum. This is very successful nowadays. It can increase the product of the methane instead of only the methane and CO2. So we can increase the methane ratio to the CO2. We can also produce butanediol out of oil palm fronds, biocarb bio oil, gallic acid. This is very expensive, quercetin. And this is where if you can produce it, this will be very nice. I haven't tried myself. So many options, basically. So what is the important thing? High value product. So you have to think what kind of products, how many of the products you would like to deal with. For example, if you have so huge amount of products of solid waste, then you have to think of the time of the processing. But the time processing also deal with the high value, the value of the products. For example, if you would like to have some bioethanol, that it will take a very big fermentation with a huge amount of the solid waste. But also you end up with a very low price. The bioethanol is low price. So profit is the king. You have to consider how much profit you would like to have. So the next of my slides will discuss with this option. For example, ethanol, the price is only 1.4 to 1.45. So it is not interesting. This is a liter of gasoline equivalent. For example, the gasoline price is now 1.19 per liter. So with this price and with the efforts to make ethanol, there is no big difference, and gasoline price is lower. So it is very uninteresting to produce ethanol, bioethanol nowadays from the palm oil empty fruit bunch. Oh, okay. Although we need it very much for our mixed energy policy in Indonesia and also all over the world. But if you can see other products such as formic acid, the price is higher, 1.5 to $2 per kilogram. So this is the price. Still, this is a Chinese FOB price, but still considerably very stable and a little bit increasing because we need a formic acid for many purposes. For Indonesian case, for example, formic acid is used or utilized for producing rubber, natural rubber. We use a lot of formic acid. So if you go to the Sumatra, anywhere in Sumatra or in Borneo, you can smell formic acid. Even in the middle of the city, you can still smell of the formic acid processing of the rubber and also processing the palm oil itself. So the formic acid market is growing. It's growing very interesting. So Indonesia can produce formic acid, but is it is it our benefit? Let's see the other one. Furfural, for example, the price is double now, 3 to 4 US per kilogram. So there is an increasing demand. I cannot find a more current demand. This is a bit obsolete, but still growing. And also the price of levulinic acid, for example, this is double than the furfural. So it is 8 times than the ethanol. So why should we produce bioethanol? Why don't we produce levulinic acid? Or do we have to produce both? Because we need both. We need the profit from the levulinic acid, because the levulinic acid need in the world is not so very much. The player is also not only 3, the big players in the world. It's still increasing, and our belief that with the increasing of the use of biodiesel, the levulinic acid, which is very good for additive of biodiesel, this is the additive of biodiesel, and also this is the precursor for making biodiesel. So I think the growing markets of levulinic acid is very interesting. The player is only 3 in the world nowadays. So the growing market is not only from the biodiesel, but also for pharmaceuticals, agriculture, and also food additives. So it is very interesting for Indonesia if you can produce. So how we deal with this? How are we going to produce bioethanol, or are we going to produce levulinic acid, furfural, formic acid? How we deal with this? I have done my homework using a simulation, using laboratories scale work to produce all of them. So I come up with the feasibility study where we can do all the math and simulation. I'm going to show you. This is how we produce palm oil empty fruit bunch from drying, grinding, washing, alkali pretreatment, filtration, washing, hydrolysis, distillation. We end up, we got the hydrolyzed product from different runnings. This is levulinic acid mixture, A and B, and this is furfural mixtures. So we can see the difference here. Then we also do the calculation with simulation, SuperPro Designer. This is what it looks with the process flow diagram. Then we use this kind of parameter, the currency US dollar, construction period, and etc. etc. And for example, this is the price, 5,000. This is the very low price per ton. You can see that per kilogram is already $5 to $8. So that is the bulk price, not the retail price. If you see per retail price, it's more than that. Sometimes 5 times than this price. Furfural is this price, and formic acid is this price. So this is the result. So I will show you. Jump into this executive summary. The total capital investment is around $12 million. Interesting is the NPV is plus, and the payback time is 6. This is the best that we can have in our simulation. When we sell it 5.75, when we sell it only 5, then it is about 7 years. So this is what my students in the lab, and this is the pilot scale one. Yeah, but unfortunately during the pandemic we stopped all of them. We have done our mini pilot plan. This is the PLC, and also the control that we can control by wireless. Yeah. And it's my student. He already graduated. Now he's going to Germany to continue his study for PhD. I just want to show. Okay. Before we end, I just want to show you one. I forgot to put it here. That we have done our comparison of study comparison with what the German people, especially with the group of Brigitte Kamm in the northern east of Germany. We compare our study is not very far from their study, but because they're using rapeseed solid waste, we have more cellulose, then we are better than them. But because they are using rapeseed solid waste, they have softer food. Then they don't need a very hard pre-treatment in the beginning. But so their operating cost is lower than our operating cost, but the capital expenditure is almost the same. So this kind of simulation, this kind of mathematical works is very useful to discuss what, after we discuss what kind of pretreatment, then we have to discuss, we have to do our work in the simulation. So it means that what is it beneficial for us to continue the process or not? So with this, I would like to conclude my work. So if you're interested, please see my book with my friends Malaysia here. This is it is already it is in print nowadays. So it will be early of next year, January. Biorefinery of oil producing plants for value added products. So by this, you can choose any kind of product. So thank you very much. I will give floor back to the
kan ada pertama si Siska, terus anaknya Pak Barnel itu, makanya dipanggil Pak Barnel yang dikejar hari ini.
Can you please mute participants? Okay. Thank you very much, Professor Misri Gozan. Very interesting topics. Sorry to have you only for 20 minutes because we really like to hear more about it. Yeah, because for your information, in SGU, we have also researched regarding palm oil fruit bunch and also a biodiesel additive. Therefore, we are very interested in your research regarding, especially in levulinic acid. Therefore, please open your door if we have some questions through your email from the participants and also from other lecturers in SGU.
Yeah, I welcome any questions, email. I will give it to Pak Moderator. Unfortunately, I have to withdraw because I have to have a rest now.
Yes.
Sorry, not good. Okay.
Yes.
Thank you very
Many
much.
thanks, Professor Misri Gozan. So I heard that you are now during your quarantine period. I hope you have a speedy recovery very soon and come back stronger. Thank you very much, and respected Professor Misri Gozan. Good morning. Ladies and gentlemen, we would like to proceed to other presenters. Here now we have presenters from SGU. The first presenter will be Sylvia Yusri, Master of Science. Sorry, Sylvia Yusri, Master of Engineering, with the title of Biodiesel Additive Performance from Tertiary Butyl Hydroquinone and Surfactant Glycerol Monosterate. For Ms. Sylvia Yusri, you can start your presentation now.
Okay, thank you, Dr. Harris. So I will share the screen first. Sorry. Okay, so can I start the presentation?
Yes, sure. please.
Okay, so good morning for the participant and the guests. Today I'm going to present my research project titled The Biodiesel Additive Performance from Tertiary Butyl Hydroquinone and Surfactant Glycerol Monostearate. So this research project is funded by the RCS through the CRF. Okay, here are the outline of my presentation today, and I will start with the background. The International Energy Agency reporting that there was an increase in the total energy demand as much as 0.9%. And among the several types of the primary energy, the fossil fuel contributes about the 84%. And as we know that the fossil fuels contribute the negative impact to the environment because it causes the carbon emission, and it also the main cause for the global warming. So we need to shift to the renewable energy. And biodiesel is one of the biofuel that can be used as the potential replacement for the fossil fuel. Indonesia, as one of the largest biofuel producing countries, is currently implementing the B30. The B30 is the combination between the 30% of biodiesel and 70% of petrodiesel. And the government plans to increase the portion of the biodiesel in diesel fuel up to 50%, and it is very possible for Indonesia because Indonesia is one of the largest producer for the crude palm oil. So for your information, the crude palm oil is the main raw material for the biodiesel production. As a biofuel, the biodiesel has several advantages because it is renewable, and it also non-toxic and clean energy, and it also easy to implement. So there is no need to modify the diesel engine to use the biodiesel. But unfortunately, it has the main weakness because it has the low oxidative stability due to the double bond content in the structure. So if the double bond, if there is a contact of the double bond with the oxygen, so the biodiesel will be oxidized. As the result, it will produce unwanted products such as sediment and also the viscous liquid, and it may harm the engine. So the addition of the antioxidant is necessary to maintain the stability of the biodiesel. So we need to add the antioxidant to the biodiesel, and most common antioxidant used in biodiesel is polar compounds such as the phenolic. And on the other hand, the biodiesel is non-polar compound, so there is a polarity gap between these two materials. So we have other problem because the antioxidant has the low solubility in biodiesel. And in order to improve the solubility and the performance of the additive in biodiesel, so at 2019, Sutanto studied the performance of the TBHQ or tertiary butyl hydroquinone and the glycerol monostearate as the biodiesel additive. As you can see in the picture, you can see that the addition of additive in biodiesel is able to increase the solubility and the stability of biodiesel in terms of oxidation. It increased the induction period of biodiesel from 3.9 hours to 20 hours. So it also comparable to Bionox. So Bionox is one of the commercial biodiesel additive from Germany. So I think that it is potential for us to develop this product as our own additive for biodiesel. However, to measure the performance of an additive, we need to examine several parameters related to oxidative parameter in SNI, so which are the acid number, the iodine value, kinematic viscosity at 40 degrees Celsius, and also the induction period. So at the previous study, we only focus on the induction period. So for this research, we are going to reevaluate the performance of this additive the TBHQ and GMS in 4 parameter oxidation, the acid number, iodine, kinematic viscosity, and induction period in pure biodiesel from crude palm oil. And for the methodology, first we have to prepare the sample. The sample content of 2 samples. The first is pure biodiesel from CPO, and the second one is biodiesel with addition of TBHQ and GMS. And for testing parameter, we're measure for 4 weeks of storing period. And here are the results of the testing. The first parameter is the acid number. So why the acid number is important to check the performance of the additive? Because when the biodiesel is oxidized, it will produce the hydroperoxide, and the hydroperoxide will undergo the further reaction to produce the organic acid. So the increase is in organic acid indicates the oxidation occurred in biodiesel. The higher the rate of the formation of acid, so the higher the rate of the oxidation in biodiesel. And here are the data for the biodiesel, the pure biodiesel and biodiesel plus additive. As you can see that there is an increase of acid number for the both sample from week 0 until week 4, but we can see that the biodiesel with additive has a lower acid number and also a lower slope or a lower rate of formation of acid. So we can conclude that the addition of biodiesel is able to maintain the stability of biodiesel in terms of acid number. And the next one is iodine value. So in iodine value, why we have to measure the iodine value? Because we can have the information about the number of the double bond in the biodiesel. So as I mentioned before, the higher the number of the double bond in the biodiesel, so it will be easier to be oxidized. So here are the data about the 2 samples. So we can see that the number of iodine decreased from week 0 until week 4, but we can see that the sample of biodiesel with additive has a lower slope or a lower decrease of double bond. So we can conclude that it shows a significant improvement in maintaining the stability of biodiesel in terms of iodine value. And the third one is the kinematic viscosity. So as I mentioned before, the oxidation of biodiesel will produce the hydroperoxide, but the organic acid is not the only product from this reaction. It also produces the polymer. So the production of the polymer in here will increase the viscosity of the oil. So we can also evaluate the increasing of viscosity in biodiesel, the pure biodiesel and biodiesel with additive, but we can see any significant difference or any significant effect due to the addition of the additive. And the last parameter is the induction period. So the induction period is the most important parameter that should be tested to know the stability of biodiesel in terms of oxidation. So as we can see that the blue one is the biodiesel, the pure biodiesel only without the addition of tertiary butyrhydroquinone and surfactant GMS. We can see that the induction period was dropped from about 1,400 minutes to 660 minutes. So there is a big drop from about 40%. But if we can see that the other product, the biodiesel with additive, so we can see the small drop in the induction period. So we can conclude that the additive was able to maintain the stability of the biodiesel. And as the conclusion, based on the 4th parameter, we can see that the addition of the additive show a significant improvement in the oxidation stability for biodiesel, but there is no significant improvement in terms of the kinematic viscosity, and all the parameters comply with the SNI standard. So for the further study, we plan to do the further research. We conducted a longer time period for the storage, and also we have to do the test with the several concentration of biodiesel. So that's all from my presentation. So thank you.
Thank you very much, Ms. Sylvia Yusri. For the Q&A session, I would like to invite Dr. Dia Widi Putri as a reviewer to ask question, maybe one question only to Ms. Sylvia Yusri. Please, Dr. Dia. You're still muted, Dr. Dia.
Okay, sorry. Thank you very much, Dr. Harry, and thank you, Ms. Cecile or Sylvia Yusri for the presentation. It was very clear and straightforward. I would like to just ask probably not really one question, but 1.5. So the first one is a small question. I want to know first where is the addition of TBHQ and GSM required during the process of biodiesel production? Is it added at the end when the product is already there, or during the process of production?
Okay, so for the first question, we need to add the addition after the production of biodiesel. So before,
after production, okay.
Yeah.
So after the biodiesel is ready, then the mixing with TBHQ and GSM will take place. Okay, yes. Thank you very much. So then has there been any check done, or whether the combustion performance or the effect of the addition of TBHQ and GSM will have on the machines, for example, later, because this is going to be used in a combustion machine?
Okay, so for now we have no information about the effect of this addition into the combustion of biodiesel. But as we know that the additive consists of organic compounds, so we assume that it will be convert to CO2 and H2O after the combustion.
Okay. And yeah, then my last question, just to confirm, you have tested 4 parameters, and I can see that 3 out of the 4 parameters have shown good results as expected or as hoped, but the kinematic viscosity did not show any significant increase, right? But when even though the kinematic viscosity didn't improve or did not increase, was it still, or is it still in the range of the standard recommended?
Okay, so let me show you the standard for the kinematic viscosity. So the range for the kinematic viscosity is about 2.3 under 6. So it's still in the range of, so it's complied the SNI standard.
Okay, even though there's no significant difference. Okay,
yeah.
Thank you very much. That's all from my side.
Many thanks, Dr. Dia, and many thanks also for your presentation, Ms. Sylvia Yusri, Master of Engineering. Thank you very much. Ladies and gentlemen, for the next presentation, I would like to invite Dr. Samuel Kusumo Cahyo, which will present his topic regarding ultrafiltration membrane.
Okay.
Hello, good morning, Dr. Samuel.
Yeah, thank you very much, Dr. Harry.
Okay.
So can you see my PowerPoint?
Yes, but yes, now. Okay. Yes.
Okay, in the full screen. So good
Please,
morning,
Dr.
ladies and gentlemen. Okay, good morning, ladies and gentlemen. So today I would like to present about the utilization of PET bottle waste as material to develop ultrafiltration membrane. And this is the theme. And first of all, I would like to introduce to you about membrane technology. So this is one of the newest separation technology with the mechanism is based on the difference in the particle or molecular size. So we have here feed, and then this is the membrane. So we can use it for liquid separations, as well as for gas separations and also liquid solid separations. And because of the difference in the molecular size or particle size, we can separate two different liquids or gases or solid and liquid. And the advantages of membrane technology is that it requires only low energy, and then no heating process is necessary, and the membrane itself shows high selectivity. And there are many types of membranes, so like microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. But today I would like to focus on ultrafiltration. This is the process of ultrafiltration. The application of ultrafiltration membranes in industry, mostly for water treatment, and in pharmaceutical industry they use it for also water treatment to remove virus, bacteria, or macromolecules. And also in food and beverage industry, they use for protein concentration, for example, and also purification of product water. And the polymer material for commercial ultrafiltration membranes are usually polysulfone, polyether sulfone, and cellulose acetate. But unfortunately, these materials are not produced in Indonesia, and all of them must be imported. That's why we are interested in using polyethylene terephthalate or PET that is abundantly produced in Indonesia because of its excellent mechanical and chemical property. And PET is commonly used as material for packaging, such as plastic bottle. But as you know, the plastic bottle creates a serious environmental problem because this is a single-use packaging, and we can see millions or billions of PET bottle waste in our environment. And the objective of this research is to utilize PET bottle waste as raw material to develop ultrafiltration membrane, which can be used for water treatment. And we want to compare the chemical structure, microstructure, hydrophilicity, and porosity of the membrane prepared from PET bottle waste and those from pristine PET resin, because the PET bottle waste itself is made from PET resin originally. And then we want to study also the effect of additive on the membrane microstructure, hydrophilicity, porosity, and ultrafiltration performance. And let me introduce to you the research design. So we use PET bottle waste and or PET resin as polymer material, and then we prepare the membrane by phase inversion techniques, and then we can produce the ultrafiltration membrane, and then we analyze the membrane using FTIR to analyze the chemical structure, using SAM, EFM to analyze the microstructure and surface roughness. And then we use also water contact angle measurement to analyze the hydrophilicity of the membrane, and gravimetric method to analyze the porosity. And then we conducted also ultrafiltration experiment to measure the permeate flux and rejection of bovine serum albumin. This is a solid model to determine the rejection of the membranes. And this is the pre-treatment process of the used PET bottle. So we remove label, bottle cap, washing, and then cut into small pieces. Then we use, this is the shot of PET bottle, and this is the photograph of the PET resin. So the PET bottle is produced from the PET resin. So we want to compare. So we heat phenol, we use it as solvent, and then dissolve the PET bottle in phenol and also the PET resin, and then we add PEG 400 polyethylene glycol as the additive, and then we blend both polymers, and we obtain the casting solution. Then the casting solution was cast onto a glass plate and immersed in non-solvent containing ethanol water to create a pore of the membrane, and then we can obtain a flat sheet ultrafiltration membrane. So this is the composition of the membrane casting solution. So we varied the concentration of the additive to know the effect of the concentration. And this is the ultrafiltration experiment setup. And then we measure here the permeate flux is the permeating component through the membrane. So this is the membrane. And we also measure the rejection of the membrane for PSA molecules using this by measuring the concentration of PSA in the permeates. And then this is the results of this experiment. So this is the photograph of the membrane prepared from PET bottle waste, and at the right side is the membrane from PET resin. So there is almost no difference in the appearance of the membrane. So this is a flat sheet membrane with a thickness of about 140 micrometer, very thin film. And we analyzed the chemical structure of both membranes. This is membrane from PET bottle, and this one is from PET resin. We also found there is almost no difference in the chemical structure by comparing the FTIR spectra. So this is the interpretation of the FTIR spectra based on the chemical structure of PET here. So we can study the bonding of the membrane using the FTIR. And this is the same images of the cross section of the membrane. The left side is membrane prepared from PET bottle waste, and at the right side is membrane from PET resin. And this is the cross section of the membrane. It's a porous membrane, and this is the surface. So the surface is a smooth layer, and we also see almost no difference in the microstructure of the membrane. And this is the bigger magnification of the cross section. This difference is only the the interconnected pore using the PET resin, but the pore size itself is almost the same. And then this is the atomic force microscopy image of the surface of the membrane. So we can see here the surface of the membrane, and the surface showed a typical nodular hills and valleys morphology with the mean surface roughness of 232 nanometer. And this is common for ultrafiltration membrane. And this is the comparison of the porosity and hydrophilicity. So there are almost no difference also in the porosity, and the water contact angle showing the hydrophilicity. And then the permeate flux from the experiment, microfiltration experiment, there is also almost no difference. So we can conclude that we can use PET bottle waste instead of using PET resin, so that we can also conserve the environment by recycling of PET bottle waste into ultrafiltration membrane. And this is the effect of polyethylene glycol as additive. So we can see that increasing the concentration of PEG resulted in a decrease in the pore size of the membrane, because PEG itself acts as a pore reducer. And interestingly, that the porosity of the membrane increased by increasing the additive concentration. So this is without additive, it's about 69.5%, and then increase sharply to 79%, and then become constant. And water contact angle also decreased, indicating that the hydrophilicity of the membrane increased by increasing the PEG concentration. And then this is the permeate flux, the effect of additive on the permeate flux. You can see also the increase of the permeate flux. So this is permeate flux using 4% PEG, and we increase to 5%. We can see a sharp increase in the permeate flux. and then become constant by increasing to 7 to 11. And interestingly, the rejection of the membrane increase also with the increasing additive concentration. So this is the illustration that PSA molecules with molecular weight of 66,000 Dalton is rejected by the membrane, and then water permeates. So as a conclusion, so ultrafiltration membrane prepared from used PET bottle showed the same chemical property, morphology, porosity, and hydrophilicity with that prepared from PET resin. So we can conclude that instead of using PET resin, we can use PET bottle waste to prepare the membrane. And the use of additive PEG 400 increase the porosity and hydrophilicity, but decrease the membrane pore size. As a result, both permeate flux and rejection of PET membrane improve by increasing PEG concentration. So as acknowledgement, this work has been financially supported by the world-class research grant program from Cambridge Technique. And this is the research output. We have two Scopus Index Q1 journals and two presentation at international conference and one patent registered to Haki. Thank you very much.
Thank you very much, Dr. Samuel Kusumo Cahyo, for your presentation on the field of environment. For the next session, I would like to invite Dr. Maria Gunawan Putri. Committee, can you please spin Dr. Maria? Yes, okay. For the question, please, Dr. Maria Gunawan.
Thank you, Pak Heri. I would like to ask two questions to Pak Samuel. One is actually, both of them is based on my experience with the bottle waste. Yeah. I have my first questions is about the strategy to collect the bottle waste. You know, sometimes we try to separate our waste, but later on people will mix it up again. Do you have any strategy to collect your material?
That's right. So in Indonesia itself, we do not separate the waste like in Japan, I know, or in other countries. I think we have to start with the policy from the local government, maybe not the central government, but from the local government to separate the waste like plastic and other organic waste. And then especially for PET bottle, like in Japan, we have to collect it separately for PET bottle because we have a lot of PET bottle. And then there is a mark of recycle at every bottom or surface of the PET bottle so that it can be recycled. So basically, the idea to collect it, the PET bottle separately is very important. So we have to start. We can start maybe from our campus, for example, after you drink the, for example, aqua, or mineral water, and you collect it in a separate bin, for example. So we can start from small things by separating the PET bottle.
Thank you, Pak. My second question is about the cap of the bottle. When you were in Japan, or myself was in Japan, and I got to know that actually the cap bottle have a better plastic quality than the bottle itself. Is it possible to use also the cap membrane? If so, is there any difference in the treatment?
Yeah, actually, the cap itself is usually made from other polymer materials like polyethylene or polypropylene, and I think we have to start a research also in utilization of polyethylene or polypropylene as a raw material for membrane. So this is maybe very good topic for the next research, because this is not PET.
Okay.
So the body of the bottle itself is PET.
Okay.
Yeah.
Thank you, Pak.
Okay, thank you very much, Dr. Maria Gunawan Putri, for your review. And I would like to ask Dr. Samuel to stay because Dr. Samuel has to present another topic, different topic. I'm going to read the title, Fabrication of Alumina Kaolin Ceramic. Wait. Fabrication of alumina kaolin ceramic microfiltration membrane for biodiesel purification. So it's like a bridging between the environment and the renewable energy. Thank you very much. Please, Dr. Samuel, you can start to present your.
Okay, thank you, Dr. Harry. So actually this presentation must be presented by my student, Natasha, but unfortunately she cannot attend this SGU Symposium because of sickness. So I will give the presentation. So this is about fabrication of alumina kaolin ceramic microfiltration membrane for biodiesel purification. So as a background, as you know, this morning we also heard from Pak Nuki about the energy consumption in the world, and in Indonesia has increased sharply. On the other hand, the depletion of fossil fuels become a problem. That's why, and also the carbon emission from energy use has to fall 70% by 2050, according to BP Energy Outlook. And Indonesia has already started by using renewable energy instead of fossil fuels. One of the renewable energy is biodiesel, as presented by Ms. Cecile also this morning. So biodiesel is promising alternative energy to replace biodiesel fuel. And then it is produced usually by trans-esterification reaction of vegetable oil. So Indonesia using palm oil with alcohol like methanol in the presence of catalysts like sodium hydroxide. And but unfortunately, glycerol is also produced as the main byproduct. And glycerol in the biodiesel will reduce the quality of biodiesel because it causes problems in the diesel engine. So it must be separated from the biodiesel. And the conventional method to separate glycerol from biodiesel is using wet washing or water washing, using water, but we have to use 10 liters of water for 1 liter of biodiesel. So it creates a large amount of wastewater, and after that we have to treat the wastewater. So it is high cost and high energy consumption. So we propose an alternative purification technology using membrane. So this is the mechanism as I explained in my presentation previously. But this time we focus on the development of microfiltration membrane. We expect that glycerol agglomerates will be rejected by the membrane and biodiesel will pass through or permeates through the membrane. Wait a minute. Okay. So this is the separation mechanism. So glycerol form agglomerates with water in the biodiesel, and the size is about 3 micrometer. And then we develop a membrane, ceramic membrane with pore size also about 3 micrometer to 2 micrometer to 4 micrometer. And then we expect that biodiesel molecules, which is very small with a molecular size of 1.5, will permeate, while glycerol water agglomerates will be rejected. So this is the membrane we have developed. This is a tubular alumina kaolin ceramic membrane. It was prepared by slip casting method using alumina and kaolin. So kaolin itself is abundant in Indonesia, also alumina. Kaolin is a mixture of alumina and silica. Usually it is known also as a Chinese clay. So it's very cheap. And the objective of this work is to design the membrane module and then to test the membrane for the separation of glycerol biodiesel. And this is a methodology. So we design the membrane and the module, and then we use it for microfiltration experiments. Using the feed solution is pure biodiesel, and also biodiesel containing glycerol as the feed solution. Then we measure the permeate flux and also glycerol rejection. And this is the microfiltration experiment setup. So the design of the module is here, and then this is the membrane module, and we collect the permeates. And this is the feed tank containing pure biodiesel or biodiesel containing glycerol. And we can determine the permeate flux using these equations by collecting the volume of the permeates. And then we analyze the glycerol concentration in the permeates using this method, using Malaprate reaction, and then we use UV spectrophotometer to determine the concentration of permeate concentration. Then we can calculate the rejection using this formula. So this is the result of this work. This is the permeate flux of pure biodiesel as a function of time. So you can see a relatively stable permeate flux, about 60 to 70, depend on the pressure, but the pressure itself doesn't have any significant effect because the difference is very small. And then this is the permeate flux when we use biodiesel containing glycerol. So there is a decline in the permeate flux because of the fouling phenomena. So the fouling phenomena happen in every membrane. But the most important thing is we have to know what is the flux decline ratio. So we calculate the flux decline ratio is 31%, which is quite small compared to other polymer membrane, especially, which has a flux decline ratio usually more than 50%. And this is the glycerol rejection. At the beginning, we have 95%, and then decrease slightly to about 80% here because of the fouling phenomena, but it becomes stable after 120 minutes. And then, after using the membrane for biodiesel and glycerol separations, the pores of the membrane is blocked with the glycerol. And that's why we have to wash the membrane. And then after washing, we check again the permeate flux. And then we can see that the permeate flux return to about 50 liter per square meter. And then we can calculate, we call it this one is a flux recovery ratio is almost 70%. That means 70% of the permeate flux compared to the original permeate flux. And then how to increase the flux recovery ratio? So we have to do the next experiment is the washing method. We wash only using water and biodiesel in this case, but it's okay. 70% is quite high, but we can still increase. And this is the effect of pressure after washing. So we can see the increase of the permeate flux with the pressure because microfiltration membrane itself is a pressure-driven separation process. So when we increase the pressure, then the permeate flux will increase. So as a conclusions, alumina kaolin ceramic microfiltration membrane can be used to separate glycerol from biodiesel. And the membrane showed a high permeate flux of 42 liter square meter hour and a glycerol rejection of 77.5% at a pressure of 0.5 kilogram per square centimeter. So this research is still ongoing. It is funded by FRF and PDUPT Research Grant Program from Kementerian Pendidikan, Kebudayaan, Riset, dan Teknologi Republik Indonesia. Thank you very much.
Thank you very much, Dr. Samuel Kusumo Cahyo. For the next session is the Q&A, which will be brought by Dr. Dia Huidi Putri. Come to you, please. Yes, okay.
Okay, thank you very much. Thank you, Mr. Samuel, for the presentation. I would probably just want to ask several questions. First of all, you showed also the data on how the permeability dropped, or the permeate rate drops. Permeate flux dropped from time to time when separating glycerol from the biodiesel in your experiment. And my question would be, what is then the suggested backwash period using this membrane? At what permeate flux should we actually do backwashing?
Yes, actually, of course, we expect to have a flux recovery ratio of 100%, but it is impossible for all membranes. It is impossible to return the permeate flux to the original. But washing, not the washing period. Actually, the washing method is very important. What we have conducted in washing process is just using water and then using biodiesel to remove the glycerol and remaining biodiesel in the membrane. But actually, this is not really appropriate. Yeah. So we have flux recovery ratio of 70%. We still can increase to like 80%. Maybe 90% is quite difficult, yeah, but because 80% is quite good, yeah, for commercial membrane itself. It's usually just between 70 to 80. That's why not the washing period. The most important thing is the washing methodology, which maybe we want to conduct this research in the next period.
Okay, but from the information gathered from this experiment, how long is one cycle of use or of operation before we have to do backwash?
Oh yeah, we conducted the experiment for 120 minutes, as you can see here. 120 minutes, you can see the flux decline because of the falling phenomena, because of the concentration polarization. So, but we conducted also until 3 hours. Yeah. This value is actually relatively stable after 2 hours. That's why all of the experiment conducted. So this stable, but after that, if you do not wash the membrane will show a permeate flux at 0 minute at about 40. You know, so after 120 minutes, you restart the experiment, so it will shows permeate flux of 40, not 70 anymore. That's why we have to wash.
Okay, so the operating time for one cycle, let's say, is around 2 hours.
But in industrial operation itself, actually you can continue to use the membrane for 1 year or not 1 month, for example, or 3 months, because the permeate flux is stable at 40, okay, for 2 months, 3 months, and then slightly decline, maybe to 30, 20 something. And if decline under 40, then it is time to wash the membrane. So in the industrial processes, you can wash the membrane usually every month or every 3 months, depends on the membrane materials.
Okay, yeah. So related to my just a little bit to my next question about the plan for industrial upscaling. If you think that this membrane is going to be used for industrial scale, where you can increase the capacity, will it be possible to make how is going to be the strategy? Is it going to be make the membrane in bigger size, or put them together in a bigger equipment, or what do you think for your next plan?
Of course, for industrial scale, we have to use larger membrane, bigger membrane. Let me show you the photograph of the membrane. This is the membrane we use in the laboratory with the outer diameter of 10 millimeter, inner diameter is about 5. And then we have to prepare bigger membrane. So usually we are working together with PBK Balai Besar Keramik Bandung. We have already developed a multi-channel membrane with a diameter about 30 centimeter. Multi-channel. This is only single channel. So we can use multi-channel to increase the membrane area, and then we can put the multi-channel in the module to increase the membrane area.
Okay. Okay, thank you. I think that's it from my side. Thank you. Congratulations, Pak Sam.
Thank you very much.
Thank you very much. Yeah, thank you very much, Dr. Dia, and thank you very much also for your two presentations, Dr. Samuel Kusumo Cahyo. Ladies and gentlemen, we are finished with the Research Center on Renewable Energy, Environment, and Energy Conservation. For the next session, it will be from Research Center of Food and Health. Therefore, I would like to invite Dr. Maria Gunawan Putri as a moderator. Dr. Maria Gunawan Putri is the head of Food Technology Department, Faculty of Life Sciences and Technology, and she's also the head of Food and Health Research Center. So I will give the session to Dr. Maria Gunawan Putri. Thank you very much.
Thank you very much, Pak Dr. Heri. I would like to call Pak Kuat Triana to come to. Thank you, Pak Kuat, for coming to our symposium. Before you start the presentation, I would like to introduce a little bit of, not a little bit, actually. Your CV are amazing. I don't know where to start, but I'm trying to introduce you. Professor Dr. Kuat Triana is head of Department of Physics, Faculty of Mathematics and Natural Science in Universitas Gadjah Mada. Professor Kuat received the doctorate degree in 2004 from Graduate Study of Engineering Science in Kyushu University in Japan. It amazed me to see a lot of lists of patents. Pak Kuat Triana have 8 listed patents, and only during 2018 to 2020, Pak Kuat Triana is leading 5 research grant project and also published 50 of publication only on a very short period of time. And he recently became very famous for his as a principal investigator of the development of electronic nose for fast and non-invasive diagnosis of COVID-19 based on volatile organic compound of bread. So without further ado, I would like to welcome Pak Kuat to present the presentation. Thank you, Pak.
Can you hear my voice?
Yes.
Okay.
Clearly.
Thank you very much, Ibu Maria. I'm sorry. I'm in a slow response for some WhatsApp message. Let me share my presentation. Okay. Okay, you can see my presentation?
Yes, clear.
Yes. Okay. Okay, first of all, I would like to thank to the organizing committee, especially my best colleague, Dr. Dedi Wicaksana, to invite me to share some of one of my research. And also, I would like to thank Dr. Maria for introducing my CV. And today, I would like to share some experience about how to start from electronic nose in general to be genus C19 for rapid screening of COVID-19 from bread. As mentioned by Ibu Maria before, that I'm from the Department of Physics, Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada. And at this moment, we still also have a virtual meeting with ITM Malaysia and research collaboration. So maybe I cannot join for the whole time of your nice symposium today. So I would like to start from the outline of my talk. I would like to start from the motivation why we are doing some research about electronic nose, and especially for genus rapid screening for COVID-19. Then I would like to continue with the genus as AI-based medical devices, maybe related to the performance of this issue, related to the genus at this moment, and then future research of, that we are doing now on the some new topic of research also. So I would like to start from the our dilemma actually. The dilemma of innovation during the COVID-19 pandemic. The problem is the decision to deliver innovation when it is needed by the community, especially in the COVID-19 pandemics. So we call it time to market, and the application of the precautionary principle prudent. So we have to make a prudent of this action and carrying out the standard procedure, ethical principle, and that may be the priority of this research. So start from this motivation. We then our scope, because this technically maybe it's not interesting for you. Sorry. We start from here that X-health analysis is also using the X-health analysis. We found from many papers published during last 5 years. Then we find some of them that the X-health threat from the human may be represented as a disease of the human. Indicated by a biomarker of organic volatile organic compound, or VOC, that maybe some cases can be analyzed using the analytical techniques like gas chromatography tandem with mass spectroscopy. But some paper also published, some paper also discuss about the possibility of using the electronic nose here. So some advantages or disadvantages of these two types of the X-health threat analysis, including, for example, electronic nose is possible, comprehensive for detecting the pattern of the VOC rather than detail of compound like a GCMS. So it can be used for daily application, rapid application, and so on. So also high reproducibility, of course, the for short time consuming to detect, and of course also the low cost of application. So this is a motivation of our research. So indication from the health spread can be analyzed, and it can be indication of the specific disease of the human. Also, another paper said that the breadborne biomarker of COVID-19 can be analyzed using the gas chromatography like this. For example, for the COVID-19 disease, the ethyl butanate is relatively high compared to another disease. Also, another indication like isopropanol, for example, is low concentration compared to another disease. And another indication is like acetone. It's also indication of the COVID patient is still very different from other disease. So another indication also present by another paper last year, that actually there is no specific biomarker compound for biomarker of the COVID-19, but the composition and the ratio between some compound to another compounds is very important. So that's why we are developing analysis using chemometric, or we call the machine learning or artificial intelligence like this. For example, you can make clustering, or you can make a classification with this is a positive or negative COVID-19. So start from the working principle of electronic notes, that we have doing the research. The electronic notes start from 2008, so it's a very long time we have developed this kind of electronic notes. And then suddenly in 2020, the COVID-19 pandemic come to Indonesia, and we changed the application of that. Before the pandemic, we applied for food analysis, and then for food including for authentication, and then we applied for halal detection and so on. But during the pandemic, we changed to be application for COVID-19 detection. So also start from the electronic notes connected to the ventilator, for example, the output of ventilator can be analyzed using the electronic notes and so on. Then from the disease of the patient, we will have a specific or maybe specific pattern that indicated of a disease. Then we collect by sensor array, then we make a pattern. From the pattern, then we make a data processing, then we train to the machine learning. There are a lot of machine learning model that we use a lot of this model to apply our data. After finishing the training, then we are ready to make a testing to the machine learning after training. It comes from the bacteria or virus in our lung, make a reaction, and then produce the blood organic compound. So from this issue, we can develop the electronic notes. And before continuing our research and the detection of COVID-19, we apply on the clinicaltrial.gov our procedure and our standard of clinical trial. Then it will be already approved, and then we continue to develop the electronic notes we call the Genus C19. So what we call the gold standard of the Genus is the polymerizing reaction. You know that the PCR is a very popular now because it is the gold standard of COVID-19 detection. Then from this positive or negative patient confirmed by the PCR, and then to try to make a training to the electronic notes. And this is the general specification of our device. And then, as you know, that because of we are using the 10 different sensors, and we expose the genus to the breaths of patient, then the response sensor will be like this. This time domain. This is in voltage. From here, it is a indication as positive, 76%. This is a prediction of our machine learning. And if we compare with the negative one, it's very, very difficult to identify directly by our visual analysis. So we need what we call the artificial intelligence. It is including deep learning, machine learning, and a lot of artificial model we have already trained and already to analyze. And then in the case of our recent Genus use what we call the DNN, yeah, DNN, deep neural network is also have high accuracy, high sensitivity, high specificity. And before we are mentioned to the issue of the optimum of artificial intelligence, we have to make sure that the sensor response also stable, consistency, and make electrical stability and flow rate and so on. So some part of the hardware and software must be combined with the high stability to obtain high accuracy, high sensitivity, and high specificity. And this is standard testing of the Genus, start from the profiling test in isolation room for COVID-19 in a hospital, 2 hospitals, especially in Jogja. And then all the sample, all the patient refer to the PCR reference standard, and then training to AI to make a memorize, and then the train of the Genus, and then internal validation. And then after that, we apply for the Ministry of Health, the performance tests, including the durability, electrical safety, and so on. And then finally, we did a diagnostic test, a clinical trial to COVID assessment area in many hospitals. That means the multi-center multi-center facility of health and the triple blind. And after that, we have what we call the Genus has officially obtained the distribution permit number 1, this number, to start to getting recognition by regulation, namely by the Ministry of Health, and developing deal with the COVID-19 through rapid screening. This is at this moment when we apply for getting the distribution permit, the sensitivity of the Genus is around 92%, and specificity is around 96%, and accuracy is about 94%. This is the condition when we apply the distribution permit. This is our project, how to make a commercialize the product of our research. This is a new ecosystem built from, for example, when we produce a 5,000 unit of Genus machine and consumable, that will be around 350 billion rupiah for this business, just involving more than 1,000 skilled workers and research, production, distribution, after scale, clinical, and also for services. So a lot of people can involve by this just one of our output of research. So Indonesia concern of the industrial output of our research in the laboratory, then it will be make a new revenue by the institution, or maybe by the researcher, by the laboratories. So this is about the royalty contract between PT Swayasa Prakarsa. This is startup belong to Universitas Gadjah Mada, and then we are here. UGM is owner of the Genus license, including the inventor is here. Contract with the startup from the same university, and after that there's a business contract with a production partner and also distribution partner. And this is our distribution part. This is our production partner, including 5 startup company located in Jogja and also in Jakarta. I'm the one in Jakarta, the others from in Yogyakarta. And each partner has a specific job or a specific production. For example, for PT Nanosen, for example, just design and development of core genome system module, mainboard sensor, sampling system, software, AI, after sale, and so on. It is different from, for example, from the Hikari, for example, design, fabrication of genome electronic. This is the fabrication of the hardware of the genome. And this is the mechanical production, and this is the control and automation, and this is the standard. So this is one of our experience how to make a product of our research to be a commercial one. So I share with you, maybe you will be interested in this topic of the commercialization of your product of research. And this is a issue concerning the politics and business, and then so very complicated issue in Indonesia. So during the PPKM, the use of genus is stopped in public transport. But actually, genus 1919 has been operating at some hospital. A lot of hospital now operating the genus 19 industry. Also, why industry use the genus? Because they want to make a routine screening, including the Islamic boarding school or pesantren or school and or also university use this genus right now for routine screening. So for us as inventor, there is no problem stop in public transport, because actually in public transport cannot ideal to apply the standard operating procedure compared to the hospital application. So this is some limitation of our condition right now. And this is the current future research. We are now conducting post-marketing clinical trial carried out by the Ministry of Health team and an independent clinical trial. And then Unan, sorry, this is Unan Hospital in Padang, Universitas Indonesia Hospital, Unan Hospital, and also another hospital from Unpad and also from Malang and many. And we are now preparing for international research collaboration implementation of genus in abroad, like in Malaysia, Singapore, Philippines, Myanmar, and so on. We are preparing, and right now we have already applied for ethical clearance from each country by our partner. And another application of genus, we continue to profiling test the genus for diagnostic test of tuberculosis. So it is also the main issue of our country, because we are number 2 in the tuberculosis disease in the world. So this is our problem, and we want to make some action for have a solution how to prevent the tuberculosis disease. And this is our team, full team, still very young people, and this is our site coordinator in many hospitals. And thank you very much for your attention. This is our talk. Thank you very much.
Thank you very much, Prof. Fuad. That was very interesting presentation. Yeah, I'm wondering whether if we want to order the genus, where should we go? Can we love you directly, Pak? Or we have to go to the company, Pak?
Yeah, actually, inventor is not involving in business, so we have to separate between business and research. Because if, for example, if I myself and my team involved in business, it will be a problem in, for example, improvement, because yeah, we cannot separate it between the business and research is sometimes totally different. So I think separation between inventor to the business is ideal. So some college call me how to buy, how to purchase the genus Pak. I don't know. we still just have a contact person of the distributor, and then our colleague then contact the distributor. Like this.
Okay, thank you very much, Prof. Kuat. I believe there are many questions that is directly directed, but we don't have Q&A session. Is it okay if we further like forward the questions in email or later? If you like, then you can answer it probably.
Okay.
Yeah, and also Pak Kuat, if possible, yeah, after this there is a press conference session, so you are requested to be interviewed with the media, our media partner. Yeah, please kindly go to the press conference room, and then we will continue the session.
Okay, thank you very much, Dr. Maria.
Thank you, Prof. Kuat.
Thank you, Prof. Kuat. Thank you. Okay, for the next session, we will have a Central Research Fund presentation from Pak Aulia, but Pak Aulia is being replaced by the member, Pak Dedi. Please put the spotlight on Pak Dedi, the committee. The topic of the presentation is combined chest mechanomyogram with oxygen saturation for respiratory and oxygen monitoring case study for the rehabilitation of COVID-19 patient. Pak Dedi, you have 8 minutes to present the report. Please go ahead.
8 minutes, okay. Okay, Bismillahirrahmanirrahim. Thank you, Ibu Maria. So I'm presenting actually the work of our team. Is Pak Aulia Iskandar is supposed to give the presentation since he is the team leader, but I would present on his behalf because he could not attend due to his illness.
Mas, saya kok nggak ada yang assign ya?
Okay, so the title is combined chest mechanomyography with oxygen saturation for respiratory and oxygen monitoring. So the idea is we would like to monitor how a patient, especially for COVID-19 patient, undergo the process of healing from the moment that he or she is having the illness until he is healed. And in addition to that, also recently there are this phenomena called long COVID-19. So even though the patient or the subject is already has negative COVID-19 test result from PCR or from antigen result, but there are still some remaining symptoms. Yeah, for example, the lung or the breathing system is still damaged due to the illness. So the idea is how can we monitor the rehabilitation process of COVID-19 patient. So as of March, the pandemic itself began in March 2020, and as of July 2021, we have 500,000 already vaccinated per day to reach 181 million in Indonesia. That is the target. This is some presentation of some current condition in Jakarta. Has quite high recovery percentage, 93%, while in general in Indonesia we have also quite high number of recovery of COVID-19. And then the characteristics of the symptoms are most of the people who have COVID-19, they will have fever, yeah, about 98%, and have cough symptom and then fatigue. And there are some comorbidities, yeah, related to COVID-19, among others cardiovascular disease, hypertension, or diabetes, and this could possibly worsen the condition of the patient. So the research objective of this project is to capture the lung movement, which represent the respiration rate, using non-invasive techniques without having something which is inserted into your body, or without having to take a sample, which is not convenient, but how to make a wearable device that can measure. Number two, measuring the oxygen saturation and the heart rate wirelessly. So because these two are among the most important biosignals signals indicating the rehabilitation process in COVID-19 patient. Then how can we correlate the lung movement with the lung capacity and oxygen saturation to determine the lung health condition? So these are the three devices that we are currently developing. In the middle is mechanomography device, which one of our students, Daniel, is developing. He will have separate presentation in the session later. And also another device is using oxygen saturation and for calibration and testing. And this is actually now currently quite well-known device to monitor the condition of COVID-19 patient. And what we are developing also, we try to incorporate pulse oximeter and integrate it with an accelerometer so that we can monitor the condition of the healing and at the same time also monitor the oxygen saturation within that person. So this is how the data acquisition. The accelerometer and the pulse oximeter is attached to the rib, near the diaphragm, where the movement of the breast is mostly happen. This is one typical example of raw data from the accelerometer at the z-axis, indicating the inhale and exhale step of the respiratory system. And so from here, then we can get the respiration rate as a number of breath per minute. So respiration rate is quite important parameter, because if you have low oxygen saturation, then you will tend to have faster respiration. You try to breathe faster to balance so that you can capture more oxygen. But when you are healthy and your oxygen saturation is quite high, then usually you breathe easily, just like the usual healthy person. So from that raw data, we can have further data processing using moving window averaging, signal processing, and then getting the inhale and exhale information from that raw data. And combining with pulse oximetry by placing the finger on the sensor, we can have additional data in conjunction with the accelerometer data. So we will have simultaneous triple data. So the upper part here is the red wavelength data. The middle part is the infrared wavelength data, and the lower part is from the accelerometer. An important or an interesting phenomena that we have discovered is that the infrared amplitude seems to be inverted with the accelerometer amplitude here. It means that even using the pulse oximetry, it is possible to detect the respiration rate just from the pulse oximetry. So if you see here that during the exhalation, the amplitude of the pulse oximetry infrared wavelength seems to be higher. So we can have also the blood pulse data from the SpO2 sensor here. And the data is then being put as a live stream to a web server wirelessly. Then like this, it will be captured like this and then sent to data web server. So here in the case of patient who is undergoing a healing process at home, so they do not need to be at the hospital anymore. They are discharged already from hospital because their results already negative. Their PCR result, for example, is already negative. Then how can the doctor monitor their healing, because maybe the healing process? So using this kind of telemetry, they do not need to come to the hospital or to the clinics anymore. Their data can be monitored by the doctor anytime from a web server. So as a conclusion, the prototype that we built can wirelessly send the data to the subject's respiratory activity to a local data server via Wi-Fi network. The transfer of the rate of the device is currently 10 to 50 data per second. So this is quite enough for respiration signal wave. Although for MMG later, as our student will explain in a separate presentation, we need more higher data rate to transfer the muscular activity also. Then we found a phenomena that there is a correlation between the amplitude of the infrared pulse oximeter signal and the inhale-exhale motion of the chest. So that then from there we can know the breathing cycle from the pulse oximetry optical sensor. The result of this is being published in National Journal Economica, and also we submitted one paper, not written here yet, to IEEE Sensor Conference 2021 regarding the use of MMG for monitoring breathing. We would like to acknowledge funding from SGU from Swiss German University under CRF grant. Thank you very much for your kind attention.
Thank you very much, Pak Dedi. I would like to give the opportunity for question and answer to Budia. Budia, go ahead, please ask the question.
Okay, thank you, Bu Maria. Thank you, Pak Dedi, for the presentation, and congratulations for the team of Aulia that has been succeeded to have this kind of result from the research. So probably just to start my questions, I would like to confirm first, Pak. So you have shown this prototype. So this prototype is actually already working.
Yes.
And can show the expected data, right?
Yes.
And what is the next plan for this development, Pak Dedi? So if it's wearable, then I think it should be probably reduced in size, or something that is going to be easier to be used by patients, for example. Any further plans for the development?
Yes, actually we need to package it more to be more comfortable for the user, and then conduct preclinical or clinical trials with more samples from both healthy subjects and possibly also from subject who has this illness, this COVID-19, and who is undergoing rehabilitation. So we have network with Universitas Pajajaran, Faculty of Medicine, Department of Physical Rehabilitation. So hopefully, inshallah, in the next session of CRF, we are applying for that preclinical or clinical trial using measurement of real subjects, more real subjects. Not currently, it's already, but with a single subject only, just to prove the concept of the device.
Okay, so I hope it continues, because this is very promising and very required for this pandemic situation.
Thank you.
And probably just my additional question. So if we have now, or with using this device, we have 3 data available at the same time, which are the respiration rate, the oxygen saturation in the blood, and the heart rate, right, Pak?
Yes, the blood, we have the oxygen saturation, the blood pulse also, then also the breathing rate.
The breathing rate.
Yes.
Respiration. Okay. So when as a common patient, for example, how do we interpret the danger level, or when it becomes dangerous for me? Which data is actually very significant or very important for us to pay attention to? Like when the respiration rate is still high, should we pay more attention to saturation? Or when the saturation is good, should we pay more attention to respiration rate? Or how is it actually, how to interpret the 3 data?
Yeah, actually we haven't got until that stage yet. Okay. Because that interpretation of from the combination of these data require medical knowledge. So that will be actually in the next step of this project.
Okay.
When we already gain enough data from both healthy subjects as well as subjects having illness, COVID-19 illness or other illness maybe, and from there only that we can interpret the data, and in collaboration with doctors, medical doctors who have the deep knowledge on the physical or physiology of the respiratory system.
Okay, then probably for the development later, there can be some kind of an alarm when some result is more important than giving the alarm to the indication to the patient.
So currently we just send the data like that to the web server, but later, yeah, after we obtain important information also that such system that you are suggesting to have alarm can be also integrated. So the doctor who is monitoring our healing can know whether we are doing fine or not.
Okay, very good, Pak. Success for the next future plan. Thank you.
Thank you very much.
Thank you, Bu Maria.
Thank you. Now we will continue to the next presentation. Still Pak Dedi, thank you for being with us. I hope you can present the second presentation of preliminary study on low cost point of care for COVID-19 diagnostic. Go ahead, Pak Dedi.
Thank you, Ibu Maria. So for the opportunity, so I would like to present the result of our project, CRF project, on the preliminary study on low cost point of care COVID-19 diagnostic, which we have been doing with the help of teams, lots of teams, yeah, many members from students, and some of them will present also some specific part of this project by their own presentation later. So the team members are Pak Aulia and Pak Holis. Okay, so this is, we have similar with Pak Aulia presentation. So as of yesterday, in Indonesia, we have already more than 3 million positive cases with 2,600,000 recovered. So quite high percentage of recovery, but also quite high fatality compared to other countries in the world, yeah, 88,650. So in this case, actually, to contain the pandemic, test and tracing is very important. And the difficulty, this is actually the difficulty since the beginning of the pandemic here in Indonesia. First, in the beginning, we have been mistakenly use rapid antibody tests, which cannot actually show a real-time indicator of the infection. Then currently the gold standard is RT-PCR swab test and rapid molecular assay, but in most cases it requires several days. If you go to Puskesmas, it requires at least 5 days of working days, yeah, very long time. And if you want a faster result, you have to pay a lot. Then there is this rapid antigen nasal swab test, which is quite popular. You need now to pay 150,000 more to have this. The result can be obtained quite quickly. However, sensitivity is rather low. So when you are not infected too long ago, then maybe the result it can give false negative. Then, of course, which is being used as screening, infrared thermometer, but this is, of course, can show you whether you have fever or not, but cannot really indicate what caused the fever. And, of course, genocidin, which we have just heard from Pak Kuat, the inventor itself, for screening in hospital, also previously also in public transportation. So still for genos, the acquisition cost is a bit expensive, 40 million to 60 million rupiah for the equipment. So the question is, how can we diagnose the SARS-CoV-2 virus infection at the field accurately, sensitively, and quite fast, yeah, without having to wait for too long time, and also at lower cost, yeah, not too expensive. So if possible, most Puskesmas can have it. So the objective of this research is then to develop proof of concept of portable PCR machine, yeah, using low cost of the self component. Then to utilize the in-house developed microfluidic fabric-based electrochemical device, or micro-FED, which we have been developing in SGU for this last couple of years, as a platform for non-invasive biomarker detection, especially those that are related to COVID-19, and maybe to explore other possibilities of low-cost field diagnostic. So there are these different paths that we have been undergoing during the last 1 year. First is this large part to develop low-cost off-the-shelf PCR, which consists of two. One is to try to develop new low-cost platform for PCR using fabric-based device, and also then to develop the electronic control for the PCR and then try to package them. Then using the in-house developed fabric-based electrochemical device, can be developed specific or non-invasive diagnostic for microfluidic for COVID-19. the idea originally when we planned this project is to use immobilized SARS-CoV-2 specific antibody, and then to conduct electrochemical measurement using a technique called as electrochemical impedance spectroscopy. And there is a spin-off of the project called to develop infrared thermometer, because in the PCR project we are developing CNT-coated thread as a thermistor, and we were thinking whether we can also use it for contactless thermometer development. So this is the first main project, is to develop low-cost PCR. We have been designing, I and many students here, to develop a microfluidic chamber using fabric base. So the idea is how can we mix the DNA and the primer from the sample in a specific location within the chamber device, and then conduct heating, thermal recycling, and then doing the PCR there. So here, for example, we use CNT-coated thread. CNT is carbon nanotube, coating onto the cotton thread and use it as thermistor, and then integrate it with nickel chrome wire as the heater. And this is the result of the calibration at 3-point calibration of the CNT-coated thread, at 3 different temperatures. And the nichrome heater, we tried also to heat at specific temperature, and so far the result is okay, is good, that we can reach the denaturation temperature about 95 to 98 degrees Celsius, and then annealing at 50 to 65 degrees, and then elongation. This is the 3 different steps needed in one cycle of PCR. This is the full setup. However, the result is that we have not yet cannot get yet a good measurement of the temperature, in the chamber, because of we still use simple resistance measurement, which later we need to improve in the next stage. And this is one of the electronic control development. Later will be presented as a separate presentation by Hanif and Jesse in the later. So they have developed the control system for the 3-step in one cycle of PCR, denaturation, annealing, and extension. Currently, it still takes quite time to reach the temperature, which means we need to do optimization of the thermal chamber system to make it quicker. The second development is we try to also develop bolometer. Bolometer is, as you know, in the thermometer gun, but instead of using thermopile, the thermopile itself is still imported from outside. So most of these thermogun are still also imported. We try to use the CNT-coated thread bolometer, that is soon. This is the thermistor, the CNT-coated thread thermistor, coated into the HBN-coated fabric. The HBN-coated fabric that is used as the infrared absorber, and then put inside a bolometer that will capture infrared radiation from outside using this lens. And this is the thermistor calibration result at 3 different sensors sample, and this is the calibration curve. From here, then we can obtain the coefficient, the thermistor coefficient. And the bolometer calibration, we put the thermistor inside chamber, a bolometer chamber like this with a lens, Fresnel lens. We use Fresnel lens to capture the infrared radiation, and then we do simple calibration using heated water here, and also another test using a solder I put on top of or in front of the bolometer. And this is the bolometer calibration curve when we measure directly using the resistance measurement. However, the sensitivity is not that high. So therefore, we try to use current measurement, which can have a better measurement. But however, this is not yet repeatable, since because of the pandemic, we only managed to do a single measurement. We need to get this measurement later. The last one is we try to develop microfluidic fabric-based electrochemical devices. So this is electrochemical. The team is with Elga Saki. She will conduct a separate presentation. And actually, the initial, as I mentioned, initial plan is to use antibody. But however, due to the we don't have enough funding to purchase antibody, the cost is quite expensive, and has to be imported also from outside. So instead, we pursue non-selective biomarker detection using the micro FED here, as shown here, coated with polymer membrane. So that has been presented by Pak Samuel in the morning. Yeah, so the technology is all developed in SGU. This is the look of how it is coated. We coat the dielectric part, yeah, between the electrodes using the PET membrane. Later, Elga will explain this in more detail. So this is the typical measurement of to measure the interaction between the analyte and membrane using EIS, electrochemical impedance spectroscopy. For proof of concept, we measure glucose here. This is Nyquist plot, the left part here, Nyquist plot, measurement of several concentration of glucose inside the PPS buffer solution at various frequency. And when we plot along the frequency axis, this is what we have. So when we can choose then at which frequency where the sensitivity is highest for particular analyte. For example, here for glucose, we choose 1364.74 Hertz, and we have a sensitivity of like this, 1 million ohm per millimolar, with LOD, limit of detection, 0.0186 millimolar, which is quite enough for measurement in blood or urine, for example, but not yet for saliva. We need to still.
Excuse me, Pak Dedi, is still okay.
So yeah, we have developed fabric-based chamber for PCR processing, but a better way to integrate the thermistor and nickel chrome heater need to be developed. And the CNT coated red thermistor can be better read using active temperature sensing using current measurement. And the development of volumeter using CNT coated red itself is quite difficult because the infrared optics is quite complex. Then we have been using polymeric coating as promising approach for non-selective analyte sensing and recognition. These are the publications that we have been doing during the last 1 year related to the project. And I would like to acknowledge IRCS SGU for the CRF grant. Thank you very much for the opportunity to present our work.
Thank you very much, Pak Dedi. And that was very interesting presentation. I hope the study will continue. Now I would like to give the opportunity to ask questions to Ibu Yunita. Are you there, Ibu Dr. Yunita?
Okay, thank you, Ibu Maria. Thank you, Pak Dedi. Pak Dedi, I only have one short questions related to calibration, especially for about the calibration itself. Is it also taken to the National Calibration Institute, Pak?
Not yet, so we haven't got into that stage yet. So we are the purpose here is to have a proof of concept first at this stage. So the calibration is done at the lab. So using simple devices. So for thermometer, for example, we haven't really gone into the BSN, Badan Standarisasi Nasional, or the PCR. PCR itself, for example, we haven't gone into real actual sample. We will first need to make it successful in taking making amplification. Well, the last one, for example, here is still using the sample in our lab, not yet with the actual sample let alone from the Badan Standarisasi Nasional. Not yet. Still far away to go to that stage.
Thank you very much, Pak Dedi. Thank you for the interesting presentation and discussion. Then we need to go to the next presentation. Since the limitation of time for the next presentation, it will be conducted in panels. So there will be 4 presentations in consecutive, and it will be ended with question and answer session in the end of the 4 presentation. The first presentation would be from Jacinta Stephanie Esralia Harun for the synthesis of polylactic acid from banana ham. Go ahead, Ezra. You may present. You have 8 minutes to present your presentation.
Okay. Hello?
Go ahead.
Oh, wait a minute. I think it's error. Okay. Okay, good afternoon, everyone. So, let me introduce myself. My name is Ezra, and I'm from Biomedical Engineering batch 2019. So, today I would like to present about the synthesis of polylactic acid, or PLA, from kepak banana hemp as the main materials of biodegradable surgical sutures. So, when we're talking about fabricating surgical sutures, what we really want to achieve is we want to get the result that is really close to the ideal sutures. And the characteristic of an ideal sutures itself is it has to have great tensile strength, high elasticity. It should have good handling characteristics and should be biocompatible to our body and create low tissue reactivity, and also the most importantly it has to be low cost. However, in the reality in Indonesia, the surgical sutures that are still imported from outside the country, and that will create the surgical sutures become high cost. Therefore, what we really want to achieve is that we want to create an affordable surgical sutures with the good quality, and to do that, we decided to create to fabricate the surgical sutures, synthetic surgical sutures, by using PLA. The reason why we want to choose PLA is because the first thing is it is easily to obtain, because PLA is come from the lactic acid that can be converted from the glucose, and we know that Indonesia has a lot of natural resources that contain glucose, and that is why we choose the PLA. And the second reason is because actually, PLA is already applied as a raw material for another surgical sutures. For example, is Vicryl. Vicryl is the surgical sutures of the combination from polylactic acid and also the glycolic acid. Therefore, it is proven that PLA is biocompatible to our body. So, with that reason, we found another problem where the source of glucose that we want to achieve and what we want to get. So, when we're seeing the natural resources from Indonesia, we found that banana tree is abundantly in the nature, because Indonesia is a tropical country. So, we searched about the banana trees, and we found that banana trees possess good benefits for humans' health. For example, is it can heal skin diseases, and also it can heal menstrual pains and diabetes and other diseases. So banana is proven that it can help humans, and it is biocompatible. And another reason why we use banana is because it contains a lot amount of starch, and actually every part of the banana contains starch, but the most the most high amount of starch is in the banana ham itself. And the last reason, the ultimate reason why we want to use the banana trees is because actually when banana is growing and it produces fruits, it has to be cut down because it will not produce anymore, and there are a lot of productions of banana in Indonesia, and that means there are a lot of waste. So we want to utilize the waste and convert it into surgical sutures. So basically, it's a win-win condition. So the objective of this research is that we want to produce the PLA from banana hemp, and we want to create the sutures from the PLA that are produced from banana hemp itself. And the methodology that we used is because we started from the starch, so we want to convert it first into glucose by doing isolation and hydrolysis process. And the hydrolysis process is in the acid hydrolysis, and after that, when it is converted into glucose, we test it using the qualitative test by using Benedict test. just to make sure that the process produced the glucose. And then from glucose, we convert it again to lactic acid by using fermentation. And from that, the lactic acid that is produced will be polymerized into polylactic acid. And in this step, we want to test whether the product that we get is already polylactic acid, by using FTIR and also viscometry test. And after we make sure that the polylactic acid is the product, we do the wet spinning to create the sutures. So now we're going to discuss about the results. Actually, this project is still ongoing, so we're not finishing yet about the polymerization step and also characterization and fabrication sutures. The steps that we already accomplished is the isolation, hydrolysis, and also fermentation process. Right now, we're still doing the polymerization, and due to the limits of equipments that we have to use, we still struggling about this polymerization step. So in the starch isolation, the basic idea is we cut down the big banana hump into pieces, and then we change it into powders in the powders form, and then we do the isolation by immersing it into water to separate the impurities from the starch. And then after that, we dry it, and then we change it into form of powders of starch. And then next we do the hydrolysis by using acid hydrolysis step. So we use HCl. We add it until the pH is 2, and then we boil it to 80 degrees Celsius and cool down in the room temperature for several days for the starch to broken down into glucose. And then after that, we did the glucose test by using Benedict solution, and it turns out that the Benedict solutions shows that there are greenish yellowish colors that indicates the presence of glucose itself. And then next is the fermentation part. However, actually we did a lot of batches, but because of the pandemic, so the solution is too long in the laboratory and it produced bad results, and we have to throw it away. So we did another batch for second batch and third batch, and in the fermentation batch we use Lactobacillus bulgaricus to do the fermentation part, and we maintain the pH into 5, and we did it 4 to 5 days, in 4 to 5 days. And then after that, actually,
Is it possible to fasten the presentation? Thank you.
And there are we did the polymerization. However, the result was not good. So we try to use another step, another changes in the production of polymerization, production of polylactic acid, I mean. So the next step that we will do is a polymerization step, characterization step, and also wet spinning step. Therefore, I cannot give you the exact conclusion because our project is still ongoing, but the basic idea is we want to create the PLA from banana hump, and we create the sutures from the PLA itself, and we know that the isolation and hydrolysis process is proven to produce glucose. And that's all from me. Thank you so much, and I hope I'm open to any suggestion from you all.
Thank you very much. Thank you very much for the wonderful presentation. Please stay tuned up to the end of your friends. We will continue with the next presentation. Please, Daniel Johannes Engel, can please committee host spotlight Daniel, please? Thank you. So Daniel will be presenting a respiratory assessment using CNT mechanomyography. Daniel, you have 8 minutes to present your work. Please go ahead.
Okay, so good morning, lecturers, and good morning, other guests. My name is Daniel Jonas Engel. I'm a student from Biomedical Engineering at Swiss German University, and now I'm going to present about a respiratory assessment using CNT mechanomyography for monitoring breathing activity. So, first of all, this presentation will includes a background, objective hypothesis, the methods that are being used in this research, the mechanomyography device itself, and the video capturing software to validate the MMG data. First of all, the background. This research is proposed due to the increasing case of COVID-19, especially in Indonesia. We know that it is one of the highest countries that has COVID-19 cases, and it also has the higher probability of catching a long COVID symptoms. A long COVID symptoms is a symptoms where the COVID-19 patient is already being stated cured. However, they still have a COVID-19 symptoms, which is caused by the defects in the lungs caused by the virus infections. And which is why we need a wireless wearable monitoring device that could be used to monitor the healing process of the patients. However, usually those kind of devices are either expensive or hard to reach. We need to go to the hospital or clinics to be diagnosed and tested, which could further transmit the disease itself. And therefore, the goals of this research is to develop a wireless wearable non-invasive MMG that could be used to monitor the breathing activities and differentiate the healthy lungs with the COVID-infected lungs. And the hypothesis is the device would be able to do it by detecting the muscle activity of the lungs. Okay, there are two main methods on this research, which is the mechanomyography monitoring device itself and the video-based monitoring software. The MMG monitoring device are consisting on three main actions, which is the patch, the device, and the software. The patch is used by converting the strain of the muscle activity into a resistance. Then the resistance will be detected by the device and converted into a digital signal by its components, and will be transferred to the software to be analyzed and plot and store the data. Okay. The first one is the MMG sensors. The sensors itself are consisted of CNT-coated thread, which is carbon nanotubes coated thread, that are being sewed into three meanders into kinesiology tape to be patched on the corresponding muscles. And in each end of the thread is sewed into a metal snap buttons to be attached with the device itself. The MMG device consisted of multiple components, which is ESP32, the microcontroller, a Whetstone bridge circuit for the CNT MMG patch, the digital potentiometer, a digital voltage follower, and many more, a battery and a 3D printed case, and a female pushpin button to be connected with the MMG patch. Here is the schematics of the device. And here is the actual device that already being soldered into the PCB, and on the right side is when it is on the case. Okay, so for the video-based respiration monitoring software, it uses Python 3 as its language, and it is used to validate the MMG data. First of all, it started by importing the OpenCV libraries, which is libraries that are supported to track the markers. Then we create the tracker to track the markers, and we initialize the video capture, setting multiple bounding box on the marker. and obtain the y-axis of each bounding box. Why y-axis? Because from the literature studies that we conducted for video-based monitoring for breeding actions, most of the literature stated that the breeding data that could be monitored is mostly on vertical axis because it is more feasible to be detected rather than the horizontal axis, which is why we record the y-axis and the timestamp of it and timestamping the data in real time while capturing the MMG data as well. And here is the sample of the data, video capturing data that are being tracked. There are multiple variables such as the FPS, tracker status, action status, and most importantly, the y-axis and the timestamp itself. So it could be synchronized with the MMG data to process the data. And here is the device and marker placement as well, the setup configuration for the tests that are being conducted. The markers are placed on both of the shoulders and between the MMG patches in serratus anterior. As well, the patches is being strapped in the diaphragm. Okay, so the testing procedure will be conducted for 1 minute, and the patient will follow a metronome app that will guide the patient doing breathing actions for 3 seconds each. So inhale for 3 seconds, hold for 3 seconds, then exhale for 3 seconds, and hold again for 3 seconds, and repeat it for 1 minute. So here is the result of the test. There are two main results, which is on 50 Hertz sampling rates and 500 Hertz sampling rate. As we can see at 50 Hertz sampling rates, there are multiple graphs. The blue graph is the raw data of the MMG. The orange graph is the moving average of the MMG. And the green graph is the video marker tracking data. As we can see, there are visible similarities between each graph. And both of the graph are worked in inverse y-axis. So actually when the graph is going down, the patient is inhaling, and when it goes up, it is exhaling. So the blue box is inhaling, and the red box is exhaling. And there are visible noise that could be seen, like a visible spike in the 50 Hertz sampling rates. And while we increase it to 500 sampling rates, the noise become more covering the real data. So the discussion that could be concluded in this discussion is the 50 Hertz sampling rate has a visible similarities with the marker tracker software data, and there are visible noise in the data. And as the sampling rate are increased, the noise tends to cover the graph. So, but we know it is a noise because we analyze the data by using a fast Fourier transform. So we know which frequency of the data are coming from. As we can see, the highest amplitude of the data comes from 0 Hertz, which is not the MMG signals that are supposed to be. But in the literature study that we conduct, the MMG signal is supposed to be in 2 until 120 Hertz.
Excuse me, Daniel.
Yes?
Is it possible to fasten the presentation, please? Thank you very much.
So we further analyze the data by analyzing each breathing action. So we could see that in inhale and exhale, there are differences in there are visible differences in the FFT of each actions. In exhale, it has more higher average amplitude than the inhale. Okay. When on empty hold, it has higher average amplitude than the hold version. Okay, so the conclusion of this presentation is the video monitoring app are able to replicate breathing pattern and its gestures, and there are visible similarities between the MMG data and video data for a lower sampling rate. And while the sampling rate is increased, the noise may tends to cover the graph, and for each breathing action also has a difference in amplitude frequencies. Okay, that's all for my presentations. Thank you.
Thank you.
I'm sorry. It seems like Ibu Maria has trouble with the connection. So thank you, Daniel, for the presentation. So next we have the next presenter. For the next presenter is Elga. Elga,
Yeah.
are you ready for the presentation?
Yeah, I'm ready.
Okay.
Okay.
The
Can
time
you
is
see
yours.
my screen?
Yes, please.
Okay. Okay, good afternoon all. I hope you are doing well. My name is Elga Fatima Saki. Today I would like to present my project on preliminary development of microfluidic fabric-based electronic tongue for salivary constituent discriminations. Saliva is a complex biological fluid that is produced by our salivary glands, and it consists of 99% of water and 1% of constituents, such as lactate, glucose, vitamin, lipid, protein, and so on. And these can be changed quantitatively or qualitatively because of infections or diseases. For example, if there is a virus enter our mouth and then it infect our salivary gland, and the production of the saliva may be changed. One of the potential approach to analyze salivary constituents is electronic tongue. Electronic tongue consists of sensor array, multiplexer, transducer, and the data can be analyzed using artificial intelligence. However, if we use this kind of sensor, we need to provide a large sample volume, which is it's not very effective. So to overcome this issue, microfluidic principle has been implemented in the sensor for electronic tongue. However, in this study, they use paper as a substrate material. But this paper itself has a limitation because it's very easy to damage, and it has poor delivery capability, decreasing mechanical strength, and brittle. Meanwhile, in 2018, fabric-based microfluidic biosensor has been studied well, and it possesses excellent absorbing properties and better physical properties. And therefore, from all of this information, we propose the preliminary development of microfluidic fabric-based electrochemical tank to discriminate glucose, fructose, sucrose, and fructose with the use of PET coating and EIS as a transducer. The research objective is to use a cotton fabric for the substrate and then to create it as an impediometric sensor. And the scope is just to prove that my microfluidic fabric-based electrochemical device can be used as impediometric sensor. And the development of electronic tank hasn't been included yet in this study. And the hypothesis is that with the 3 electrode, the microfluidic fabric base with 3 electrode and the PET coating can create impedance-based sensor. And then for the method itself, first is fabrication micro FED. We use electrode stencil and wax stencil got from digital cutter, and then we transfer carbon using screen printed for working electrode, counter electrode, and reference electrode. And then for the wax transfer, we use laminating machine like this. And this is the 2-dimension of micro FED. We have to fold it. This is for the bottom, and this is from the top one. And this is the ready to use of micro FED. And for the coating PET, first we need to prepare solution, PET solution, with the with combining PET bottle, phenol, and then PEG for 100. And then we prepare a non-solvent solution, ethanol and aqueous, and then aqueous itself. And then for the spin coating, we have to, before we do spin coating, we have to cover the electrode using vinyl paper. And then we did twice coatings. First is with different durations and volume. And then after each coating, the microfluidic has to soak in the non-solvent for 1 minute and then aqueous for 1 minute. And for the electrochemical characterizations, the sample preparation is PBS, glucose, sucrose, fructose, and protein. And for the EIS measurement, we use the range of frequency of 0.1 to 200 kHz with 5 points per decade. And the result is from the EIS, there are 2 results. First is Nyquist plot, and the second is a Bode plot. But now we focus on Nyquist plot first. The Nyquist plot represent imaginary part of impedance as a function of real part of impedance. And here, if you can see here, there are 2 semicircle actually, but the perfect one is the larger one, and this is actually this small one. Yes, and the use of Nyquist plot is to give us an insight about the phenomena happen on our system. So that because of this has 2 semicircles here, and we suggest that might be have the phenomena that might have 2 parallel capacitance and resistance. Like this happen in the here in the working electrode, and here with the fabric PET and our solutions. And then the second is Bode plot. The Bode plot here, it's show us the impedance over a range of frequency from 0.1 Hertz until 200 kHz. And then if you can see here, this is to tell us about the stability of our system. This quite stable, but this is not stable. It's because of the leakage. Because the leakage, it's very serious we have to face it. And then here the increasing of impedance is because of the increasing of the concentrations. It's because of might be because of the higher concentration, it may have a higher contaminations of the particle. And then by using the Bode plot, we can choose the which frequency that can produce the best performance of our micro FED, of our sensor, because we don't have any specific material to bind to specific particle. Here, for example, for the glucose, this is a frequency that being interest, and the LOD is 0.01. And then for BSA, it's here frequency LOD is 0.01889. Sorry, and for fructose, it's about 2000 the frequency, and the LOD is 0.08. Yeah. Okay. And then for the conclusion, microfluidic fabric-based electrochemical device can be used as impedimmetric sensor and potential for further development of electronica. And then the considerable performance of PET-coated micro FED based on EIS result was occurred at different frequency among constituents. And this is the recommendations. There are 6 recommendations here. First is use a proper spin coater and have to stabilize the micro FED first, and then use a specific bind coating, and then try using another material for electrode, and then choose a concentration that is in concentration in saliva, and then check the capacitance of the fabric. Okay. That's all from my presentations. Thank you for your attention. Hello. Hello.
Okay, thank you for the presentation, Ibu Elga. So I will give the opportunity to Ibu Maria again to lead this session.
Thank you very
It's
much.
already come back to this room. Please, Ibu Maria.
Yeah, thank you very much, Pak Tablik. So, Elga, please stay tuned. We will continue the presentation, and then we will go to the panel discussion session. Thank you very much. I'm sorry for my network connection. I just been kicked out and come back. Okay, so for the next presentation, we will have Hanif. Elga, thank you, and please stay tuned. Yeah.
Yeah, thank you. Yeah.
Hanif, can you please present your study to the audience, please?
Okay, thank you, Bu Maria. All right, hello and good afternoon, everyone. My name is Hanif Andarevi, and I'm so honored and pleased to meet you all here at SGU Symposium. So me and my partner Jesse Mesenduk, we are at the 2nd semester of biomedical engineering at Swiss German University, batch 2020. So we're still pretty new at this biomedical field, but we're so happy to present you our research on thermocycler in a PCR chamber. Okay. So before we dive into the thermocycler, we want to know about the polymerase chain reaction, or also known as PCR. This method is quite familiar, used by researchers and scientists for DNA amplification, and it is also used for clinical diagnostics such as COVID-19 test. And the PCR itself, it consists of 3 different steps. The first one is denaturation, or the breaking of the hydrogen bonds of the 2 strands of DNA, followed by annealing, where the primers are binded through the complementary base pairings. And then the third one is extension, the last one, or the elongation of the primers, which in order to synthesize the new strands of DNA. And these 3 different steps, it requires a very tight control of temperature within a specific time. So thermocycler itself, it is an apparatus in clinical laboratories to perform PCR and for DNA amplification. So as you can see nowadays, thermocyclers are quite expensive, and it weighs around 20 until 100 kilograms or even more. So this might be a problem for different areas because some regions might not even can afford it. So that we propose a low-cost miniature thermocycler. So this device is made of inexpensive components, and it is quite portable. It weighs around 1 kilograms, and it requires 12 volt and 10 amps power supply to operate. Okay, so one of the most vital part in a thermocycler is the chamber itself, because it is where where we put our solutions into and where the heating and the cooling step occur. So for the heating element, we use a cartridge heater. For the cooling element, we use a Peltier cell in which the hot side of the Peltier cell is attached to a heatsink and cooling fan. And then the third one, we use an NTC 3950 or a thermistor, where the NTC thermistor, the resistance decreases as the temperature increases. And when we're constructing the chamber, we want to approach the chamber components with the smallest available heat capacity and high thermal conductivity, so that we want to minimize the heating and the cooling step by the chamber component. We use a aluminum 661 here, although it has a quite high heat capacity, but it has high thermal conductivity. So that to tackle the problem with the heat capacity, we design the aluminum as efficient as possible, and then we insert the cartridge heater and the NTC thermistor into the aluminum, and we attach directly the heating block into the Peltier cell. This is the size of the aluminum. It's 20 times 40 times 60 millimeter. And for the materials required are the first one is the Arduino Uno, because when we're dealing with the thermocycler, we want to regulate the temperature. Therefore, we need a microcontroller to program the codes for the heating and the cooling elements. We also used a 5-volt relay in order to separate the high current and the low current circuitry. We use 10 kilo ohm resistor. We also use LCD screen to visualize the temperature shift, I2C adapter for the LCD screen, and the external power supply unit of 12 volt and 10 amps. So this is the circuit diagram. This is the relay, and each of the channel of the relay is connected to the cartridge heater, the fan, and the Peltier respectively, and it is connected to the Arduino. Another element is the NTC 3950, and since the resistance is 10 kilo ohm at normal temperature, we use a 10 kilo ohm resistor and take the voltage divider into the Arduino. And here are some of the photos of our experiments. And so how does the thermal regulation operate? So first of all, we want to calibrate the sensor using the Hart and Hart equation, because since Arduino Uno cannot read the temperature directly from the NTC thermistor, we want to transform the resistance of the NTC into the temperature using this equation. So since it has 3 different coefficients, we want to try the NTC at 3 different temperature so that we obtain the value of A, B, and C, and then insert it into the program. Then we move on to the algorithm flowchart. So first of all, the PCR, it consists of denaturation, annealing, and extension. It repeats for 30 times until the PCR are finished. So when the temperature is less than the ideal temperature, the heater will turn on, whereas the cooler stays off, and vice versa. This is the code for the Arduino Uno. So this one is the denaturation, annealing, and extension. And for sustaining the temperature, let's say that we, in the denaturation process, we want to achieve the 95 degrees Celsius within the 30 seconds. So we just input the duration and the ideal temperature. And we also add the average temperature program in order to minimize the interferences of the temperature reading. We also add the casing for the thermocycler. This one, we use a PMMA or acrylic glass. And on the right side, left side, and the back side of the casing, we make holes for the air regulation. And each of the elements is compartmentalized in each section of the casing here. Okay, I'm gonna play the video. So this is the Eppendorf tube when we put it into the thermocycler. And we start the machine. And then the temperature goes up into the denaturation temperature, which is 95 degrees Celsius. So I'm just gonna skip this. So when it reaches 95 degrees Celsius, it sustains for 30 seconds. And then when the denaturation completes, it goes towards an annealing process at around 57 degrees Celsius. And then it goes to the extension. And I'm gonna skip this again, maybe due to the time, yeah. So when the extension completes, Okay, it's still going up. When the extension complete, the cycle also completes, and then it goes back to the denaturation temperature. So the cycle repeats again for 30 times. And this is for the results. This is the temperature in the function of time. So the red circles are the PCR steps. The first one is the denaturation, annealing, and extension respectively. And the temperature managed to sustain the temperature within the appropriate temperature range. For example, the annealing, the temperature range, the target is between 50 until 65 degrees Celsius. And as you can see in the result here, it sustains within the temperature range also. So it takes around 800 until 900 seconds for the thermocycler to operate. And the device, it operates at a heating ramp of 0.175 degrees Celsius and a cooling ramp of 0.133 degrees Celsius. Although it might need a lot of time to for the heating and the cooling step, this still need an optimization, as Pak Dedi said. This research does not stop here. We want to develop this device even more by replacing the conventional PCR with the microfluidic system. So currently we're collaborating with the semester 4 students. So that was it for our thermocycler in a PCR chamber. Thank you very much.
Thank you very much. I was wondering whether you are doing a music rap or presentation. It is a very brilliant presentation. So we will wrap up this more amazing presentation with the question and answer discussion. I would like to call Ibu Dia and Ibu Yunita for the discussion. Ibu Dia, can you give like 2 questions, one for each presentation, please?
Okay, probably I'll start with the 2 first presentation, the one from Ezra and Daniel. I would like to ask to Ezra first. So it was well, it's quite a long time ago, so I have to search my notes first. Yeah, it was about making the developing surgical suture from banana hemp, right?
Yeah.
So probably I would just like to have to give one question here. Because you haven't really got to the result, it's still an ongoing project. You still figuring out how to actually produce the suture. So, but I just want to ask what is your expectation related to the strength of the material or the product, the suture? Is it going to be, I think I'm not really familiar with how the quality of surgical suture should be and so on. But as I know, for different types of stitches or different kind of surgery, whether it's going to be on the skin or in the inner organ or anything like that, you're going to need different types of suture. So what do you expect for your product later? On which application will this be proper or can be used? Yeah, thank you.
Okay, thank you for the question. So, what my expectation for PLA, because PLA is an ingredient that is really easily to degrade, so it will degrade fast, but not really fast for I mean like it will degrade like 2 or 3 weeks, but that's the naturals of the PLA itself. So actually the characteristic of the PLA determines the characteristics of the production will determines the results. But this product, this method is already been done with other authors, with other researchers, and they proved that the tensile strength is can support the tissue to hold the tissues. So that's the expectation that I will answer.
Okay, so even on skin, or is it only for the inner organ surgical?
On the skin, because when we're if it's in the like gastric, it's too acid, so it will break down easily. So it's in the skin.
Oh, okay, great. That's I think that's it from me, Bu Maria. Thank you, Ezra.
Thank you, Budia. Can we spotlight Jacinta for the next, please? Thank you, Ezra.
Thank you.
Next is Daniel, I think. Oh, for Daniel, yeah. Please go ahead for your question for Daniel, Budia.
Yes, my question for Daniel, it was about, oh yeah, respiratory CNT coated thread. So I just need to confirm one thing. So here you actually made research on the movement or observing the movement of respiratory, and not the respiratory in terms of breathing. Yeah. Hello, Daniel. Am I?
We cannot hear your
I think
voice.
my connection. Oh. Yes.
Test.
Okay, now we hear you.
Okay. Yes, Bu. In this research, we're more on monitoring the muscle activity and the breathing movement.
Okay, so it's not for diagnosing whether somebody still have COVID or something like that. So it's not detecting the virus, but it's like more of the movement of the muscle.
Yeah, it's more of monitoring the breathing activities itself, Bu. Like in COVID-19 cases, usually they have symptoms which is shortness of breath, which is what we're trying to detect and monitoring their breathing movements.
Okay, so any idea how is it? How do you classify whether it's going to be an okay result or a bad result?
Okay, it could be detected by the vibrations of the actions itself, and it's one of them. And the second one is usually by using the metronome app, we will see rather if the patients could help like hold or inhale for 3 seconds for each breathing actions.
Okay, great. This is supposed to be used by the doctor, right? So the doctor will be able to interpret the result, because it's quite difficult for us to actually understand. For me, I couldn't really understand to interpret the result that it showed actually.
Yes. Actually, we're trying to simplify it so it could be used by normal patients. So it could be used at their homes or by consulting on online consultation, maybe.
Oh, okay. Okay, great. So good luck for the next plan.
Thank you.
Thank you.
Thank you. So for the next, I would like to ask Ibu Yudita to ask questions, please. Ibu Yudita, you haven't unmuted. Thank you.
Thank you. Okay. For Elga,
can committee please highlight Elga and Hanif, please?
Yeah, okay. For Elga and Hanif, no, first for Elga. What is the closest things to do with regard to linkage? Because for fructose, if I'm not mistaken, there are still linkage.
Yeah, I think it's about specificity, but unfortunately, we haven't tried to detect it or to analyze the specificity of our sensor. We just use the best frequency towards a specific towards specific particle. So I think for next step, I can answer your questions, but now I cannot answer it. But for on the spot, I would like to say that we detect the fructose. We know this is fructose. It's because of the frequency, based on the frequency.
Yeah. Okay. Good luck. Okay.
Thank
Next
you.
for Hanif. Okay, it's about thermocycler. So, how many times has testing been done for the thermocycler to make sure that it's reliable?
Sorry, Miss.
How many times of testings so we know that the thermocycler is reliable?
For the previous one, for the results, we actually done for the second test, so it's pretty fast. And then we already get an appropriate results, but however, it's still not good enough for the performance of the PCR, because as you can see from my results here previously, that the heating and the cooling is still requires a lot of time. So yeah, we still need an optimization of the chamber.
Okay, thank you, Bu Maria, Hanif, and Elga.
Thank you very much for these 4 students. All of them are still studying in biomedical engineering, this German university. During your student time, you did marvelous job. I hope you continue your study and produce much more exciting study during your learning. Okay, so I will close this session and we will continue to the break. And after break, in 1:30, yeah, in 1:30 we will continue with the next session from Research Center of Food and Health. So please stay tuned and see you in the next session in 1:30. Have a good lunch.
Thank you, Bu Maria.
Bye, see you.